Thanks, Simon.
It's a
Interesting.
very
Well, you're always useful, so come on anyways, okay? Th- okay, take care. All right, Simon. Bye-bye. Bye-bye.
You saw we have a big aurora forecast coming up the next 2 nights too.
well, you'll
Yeah.
probably get to see a big one.
Yeah, the shame of it though is you'll have to work around the moon. So it might
Yes.
have to be right after sunset, right at twilight as the moon is rising. The aurora may be visible from the site that I would go to try and catch it. So I may go for that. It might be a moonrise aurora shot if I can somehow pull that off.
That'd be amazing.
That would be amazing. It would be a stitched together photo because of where the moon would rise. The aurora would be to the north and the moon would rise south by, I think it rises more southeast. If it rose northeast, it would be even, I might be able to get it in all one shot with my 14 millimeter, but I know where I would go to try and get all of it. And yeah, if I do pull it off, there may be a lighthouse in the middle of all of it. So we will see if I'm able to pull that off. That would be nice. But it will come at the expense of work, but that hasn't stopped me before.
You got a little tickle at the back of your throat, right? A little bit of a headache. It's going to be tough to be at work tomorrow early.
Yeah,
Yeah.
I may call in on site. Yeah, I'm not feeling very well. Um, I am vaccinated, but I'm not so sure I want to take a chance. I'll just
Careful,
go.
it's all getting broadcast. Your excuses are coming through.
Yeah, good point. I need to work on my excuses, make them better, more believable.
There's a good excuse that I came up with on May the 5th, 1961. I was in seventh grade having breakfast, and it was the day that Alan Shepard was scheduled to be launched into space. And I'm eating breakfast, and I go, ahem. And Mom says, David, do you have a little cough? And I said, ahem, just a small cough. And she looked at me, and she said, maybe you want to stay home. And I went, ahem. And she said, maybe. And I said, maybe if I stay home for like a couple of hours, then all my cough will be gone, and then I can go to school. And she says, a great idea. I wonder what television programs would be on this morning around that time. So after breakfast, we ran up to her bedroom, turned on the TV. We watched the launch of Alan Shepard, and it was just great. And then I went to school, my cough having gone completely. So, Adrian, I hope that happens to you too.
So my problem though is I work from home, and it will be a little harder to explain why I'm not online. But I might be able to just listen into the meetings, and that may be enough. So if unless the aurora hits later in the week, I'll have to watch the forecasts.
Well,
So
they're saying the better night is tomorrow night.
well,
Tonight's KP5, tomorrow night's KP6. Are you in a 5 or 6 region? I think you're in 6, right? Or
I would probably be in 6.
Yeah.
So I can go to the thumb of Michigan, and I can see far enough north. Last time, I think it was a 6 or a 7 on the solstice, and I saw it cleanly. And I have some images of that where I saw it really clear. Now I had to image it in order to see the colors. You could see something moving in the distance on the horizon. You could faintly see those light pillars, the light towers. You could tell something was moving, and you could tell it was sort of greenish. As soon as I put the camera to it, all of the colors of the aurora showed up, and that was an unmodified camera as well. So they were pretty brilliant. Let me see what I have. Space weather on my phone. I just have to find because I moved it around. And we have an aurora chaser who is has produced some nice photographs as well. And she uses these numbers. Yeah, so there is a interplanetary magnetic field setting, or BZ, and when it's to the south, then along with the KP levels and other things happening, it means that the aurora, the further south, the more visible the aurora becomes in the latitude that I can get to. I'm a 3-hour drive from the area in the thumb that I would go to. And tomorrow is, so full moon is tonight, or full moon happens tonight at the moment of lunar eclipse. That's full moon. So it's going to be a later rising waning gibbous, but it's still going to appear full to the eye, but it's going to be a rising waning gibbous, so it'll be rising later at night. So I think there's going to be an opportunity there. So I may go for that.
We will know tonight the exact moment of full moon.
Yes.
In the middle of the eclipse.
Yep. Which means it's gonna. Yeah. So by the time it comes around that next night, it's already a waning. It's already a waning gibbous, which means there'll be a limb of the moon that's going to be all cratered up. Which is, I like those waning or waxing gibbous 98% moons, because you see most of the disc, and then you get texture in one of those corners where it's not quite cut. There's a shadow. The Terminator shadow is still moving to cover it, and so you get detail in that little section of the moon. And once it's really full, you get the biggest, brightest disc that you have, and then the process starts all over again. Goes back to waning, and then it rises later and later. That's when all the dark sky night photographer folks are like, okay, now that the moon's out of the way, and they start taking data till moonrise, and then the cycle repeats itself. We go back to new moon, and this new moon is an annular solar eclipse in Canada, right? This is the annular eclipse?
Yeah, annular, and it's June 10th in the morning. We'll see it from just north of Thunder Bay, Ontario, and then it curves up through northern Quebec into Greenland and over to Russia.
Yeah, it's becoming time to where I've been a little too slow to get my modified driver's license, because I envisioned driving up to at least to that part of Ontario to see if I could capture some of it. I may not be able to come out with just a normal United States driver's license. So there may yet be some time for me this week to try and get a modified license so that I can. Or unless there's really no place that I can drive to see it. I've heard that I'd have to get there by plane.
Well, if you go across to Sault Ste. Marie, you can drive up to Thunder Bay and then go north from there. There's a few areas. If you reach out to the Thunder Bay RASC Center, they can let you know kind of the areas around, but there's no in-person right now because of COVID is the thing.
Yeah.
And if Ontario's still on lockdown, then you're out of luck.
Oh, that's right. Yeah, it's
because we're still on lockdown and travel restrictions and stuff right now.
So I can't just come rolling in from the US. Vaccination
It's so
papers.
Weird. I mean, we've spent so much time with this open border along here that we're all used to. I mean, I grew up in the States, then came up here to Canada, and we used to come up twice a year every year to see family. And it was just a given that border is always easy to pass through. We're two sides of the same coin.
Hello, Chuck.
How are you, David?
You.
Hey, Chuck.
Adrian?
Hello, Chuck.
Who am I missing here? Don't have a good full screen. Jared? Are you?
Bob and Jerry are here.
This clock is winding down pretty fast.
Hi, Chuck.
How are you tonight?
Yeah.
Good. I was on mute. I said hello a couple times and realized I couldn't hear me.
Yeah, I was just. Hey, Adrian, what is this modified driver's license you're talking about?
So it's a driver's license. I think you can get that. It's basically a little less than a passport. Like, you can get a passport and then go, to other countries. Of course, there's travel restrictions that I forgot to think about. But I think a modified driver's license enables you to, it's kind of like a passport for getting into Canada.
I see.
Yeah. So I don't know if that modified driver's license would get you into Peru or Chile or.
No. Of course not.
Yeah.
It's just it's the fast pass through the border. That's all it is.
It's a long drive to Peru anyway.
Yeah. Argentina. No, can't go. But so I think it's just if you're not going to travel but to Canada, and at this point I'd have to do the slickest talking ever to say, but I really need this because I have to present images to a global star party of the annular eclipse. I'd have to talk my head off to get over there. I'd bet.
Well, I think I told Kareem the other day that I flew into Canada in 1995 as a judge for the International Science and Engineering Fair in Hamilton. And I did not know the rules had changed. And I just left my passport at home. And so I kind of ended up on the Group W bench there for a while after I arrived. But the fear was not the Canadians. The fear was getting back into the United States. So
I had the same experience, Chuck. Yeah. I flew to Canada.
Yeah.
Okay. Because I'd always heard, you can just get back and forth with your driver's license.
Yeah.
Okay.
That used to be the case.
Used to be the case, yeah.
Yeah.
I
remember that.
Here I go. And they go,
flying is different because
you don't get back home ever, so.
Flying, they don't know where you came from. You might have just touched down in Pittsburgh and then flew into Toronto or something. But
the British are finding this right now with Brexit and trying to go to European countries just before COVID hit, and even now after. It's a new experience for them.
So, Kareem, what are the rules for coming to Canada? Is the border totally closed, or?
So, at the moment, the border is closed to leisure. It's still open to business travel and essential travel back and forth as needed, but it's case by case. But from what I'm hearing, there should be an opening or relaxing of the restrictions very soon, now that both sides are reaching about 50 to 60% vaccinated. It looks like everything's going to start to relax a little bit by the end of the summer, but it's by the end of the summer. We don't know
not
when.
By the eclipse.
All that makes a lot of sense. And then we have on the southern border here in the U.S., open immigration of people unvaccinated, unchecked. They're just pouring into the country. Go figure.
Go figure. That's
right.
That's really
well, and that's where the vaccination numbers. Now, if the vaccination does its task, it helps. So at least you're not catching. But I still don't know about the spread of COVID. We're vaccinated. It's not going to affect us in a way where we get deadly ill, but are we spreading it to others? And, we do have folks in the country that just for one reason or another do not want to vaccinate. So it is a dicey situation.
The whole thing is very strange to me.
Yeah.
And the ID thing is really strange too. I understand. I got caught in Canadian immigration once in Ottawa a few years ago trying to get to see Doug George. I made the mistake of saying I was on business. Whoops. I ended up being pulled into a room and I had to call him and have him send an email to the immigration officer and all this stuff. and I had a passport. It wasn't a matter of just trying to get in with a driver's license. Here in the U.S., you can vote with no ID at all. That's so crazy.
That's very true.
Even in Mexico, anybody who votes needs a Mexican voter ID, and they have your picture on it. And that's been that way for 30 years, probably. Not in the U.S.
I thought that in our state that you do need at least some kind of ID.
You can vote in Arizona with a utility bill.
Yeah.
That's bad.
You need, Wendy says you need two utility bills.
2 utility bills. Oh, there you go.
Okay. Well, you can, the heat, the electricity and cable, which I think most would have. Yeah, and that would explain the concerns raised. I think that the voting concerns, and of course we're scientists and not necessarily political, but that is interesting to know.
Yeah. Sorry, I even brought it up, but
you're no fine. We have to deal with politics too. We're scientists.
I live in Arizona, so.
Within that short distance, a precise combination of brute power and finesse would have to slow it down, maintain perfect balance, and bring it in at a gentle fall.
Surveyors reported in excellent condition. All signals look good.
I have a picture of John Hubble next to my desk.
400 feet.
Nice.
200 feet. 100 feet per second. 100 feet. 13 feet per second speed.
I love these little videos.
If Surveyor had done only this, made a perfect soft landing on the first shot after traveling over 240,000 miles against overwhelming odds, it would have been a tremendous achievement. Would have built the bridge for the
And this
astronauts,
cool drone shot
but
made in
it did much more.
1966.
Paid dividends almost unhoped for.
Nice.
Don't feed the conspiracy people.
Cool and
It's all done in a studio.
That particular one was.
And so it went on. The parade of pictures.
That's not.
Over 10,000. Remarkable as a triumph of technique, yet now routine in a way, as Surveyor's camera obeyed every command, fulfilled every request. It sent back man's first close look at the mountains, the rocks and craters of the moon. It identified such landmarks as the range of mountains known to be part of the Flamsteed crater. The excellent resolution of nearby rocks and surface indentations caused by Surveyor's footpads is helping scientists determine detailed surface physical properties. But most important is the fact
Somebody's
that
asking the
Surveyors
question,
did
how do we know
land on
these
the
vids
moon
are real?
and work.
Because they come from a credible source.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Sound is awesome.
Yeah.
On my bucket list to go to a launch like that and hear that, even if it's the last thing I hear.
Really close it will be.
Well, I'll try not to get, because I'll get vaporized as well. So, yeah, I'll try to live through it.
Okay.
Yeah, I'll let the zoom cameras get shots like this.
That's right. Hello, everybody. We have a very exciting night tonight. This is the 47th Global Star Party. So thank you for all of you that have already signed on and are chatting with us from around the world. Tonight is a great program that starts off, of course, with David Levy. We have others on as well, of course, as always. Chuck Allen from the Astronomical League will be up. And then we are looking at astrophotographer Molly Wakeling, Kareem Jaffer from the Royal Astronomical Society of Canada, Montreal Centre, Jerry Hubble from the MSRO and Explore Scientific. Christopher Go is supposed to be on tonight from the Philippines. We have Bob Denny, technologist, founder of and developer of the ASCOM platform and Alpaca. Cesar Barolo from Argentina. Maxi Falares, who created a sensation on our show with cell phone astrophotography with the lens removed. Adrian Bradley will be on with us as well. We have an after party going on, and this is only part one of a two-part series because at 4 a.m. Central, which is 0300, not 0300, it is 0900 Universal Time. We will start preparing for a 4:30 broadcast for live broadcast of the total lunar eclipse if we can get some clear skies somewhere around the world. So it's I'm excited to have a two-part series like this, and I think it'll be real interesting if we're able to capture live views of this supermoon total eclipse. The only eclipse in 2021, lunar eclipse, anyways. David Levy is coming on, of course, next. But as always, I like to say a few words about David. He is one of my very, very best friends, and he's been a guide and a mentor and an inspiration to me. And that's something that's sustained me for now decades that I've been in this industry and have known David. When I remember when I first was able to meet David, I just thought it was like, gosh, almost miraculous. You could meet someone that has discovered something, and at that time, when I first met David, it was at the Riverside Telescope Makers Conference. I'm not sure David might remember it, but I certainly remember it. He was there, he was walking across the grounds, and I'd realized that he had just recently discovered a comet at that time. I'll have to pin down which one it was, but he has contributed so much to our amateur community and to the professional community and to the world at large, and inspiring them to look up. And through his books and videos, his interviews, and now on the 47th Global Star Party. So, David, I'm going to turn it over to you.
Why, thank you, Scott. That was really a very emotional and very touching introduction. Thank you very much. And I can just say right back at you, because I consider you a mentor and a very, very close friend. Anyway, a few minutes ago, I was about to say tonight is the night of a total lunar eclipse. But now I'm going to say eclipse schmish. I mean, of all of the NASA videos, Scotty, that you have played on all of the global star parties up till now, the one I just saw, the one we all just saw, is far and away my favorite. And seeing the picture, did you watch the picture of the Saturn V going up in slow motion?
Yeah.
With the sound and everything? It was the memories it brought back. And I love it when people, especially Kareem could vouch for this, in Montreal, we're talking about, well, we're going to do this and we're going to do that, which is all well and good. But these videos that we saw and the one you played tonight shows what humanity has already done. When we set our hearts and minds to it, we can do pretty much anything. I have one thing to add about the beginning of that video. It showed the group at JPL watching the landing of Surveyor. I didn't notice, but I'd like to look at that video again a lot more slowly sometime in the future, because one of the people in that room was Gene Shoemaker. And he had told Carolyn, he said, it's not going to work. Remember Ranger, they had to launch 5 or 6 of them before we finally got Ranger 7 to work. We're going to have to go through a few of these. It's not going to work, and I'll be back in a couple of days. And the rocket took off. Everything was fine. The translunar trajectory was good. It went into lunar, approached the moon and started to decelerate. That was good. And then when the video picks up, everybody is just sitting there at the edge of their seats. And they're watching it come down, and it makes this gentle, soft landing. And everybody's looking at each other, and they're saying, it actually landed. It's the most surprised bunch of people you ever saw. What do we do now? My goodness. Anyway, I really enjoyed that. And Scotty, thanks so much for entertaining us with that wonderful bit of what has happened in our past. Thy shadow earth from pole to central sea is the first line of a poem by Thomas Hardy. It's called At a Lunar Eclipse. And he wrote it in 1903, and I think it was about an eclipse he had seen a few months earlier in London. And a lot of us are familiar with the writings of Thomas Hardy. One of his most famous poems, Lines on the Loss of the Titanic, is one of my favorite, was written just a few months after that ship sank. And but where Thomas Hardy really shone was with his novels. I read Tess of the D'Urbervilles in high school, and the novel was so depressing to me that it actually, and so deep and so powerful, and yet so wonderful, that it set off one of the many depressions I had in those years. But actually, my favorite Hardy novel is Two on a Tower. It's about a variable star observer. And I remember at an AAVSO meeting, and Adrian, you might enjoy this, somebody was talking about Two on a Tower, and he was sort of summarizing the story. And at about, when his time ran out, he was nearing the end of the story, and the person moderating that session tried to cut him off and say, your time is up. And we almost mugged him. He said, you cannot stop now. And he sits down, he said, okay, you're right. Now you explain it to me. Because we have to hear the end of this. But anyway, this is the poem that he wrote about a lunar eclipse. And what I really love about it, he talks about the moon and about the earth and the lovely, wonderful shadow of the earth compared to the kind of earth we all live on. And I think this is so appropriate to the earth we live on right now. And here it is. Thy shadow earth from pole to central sea now steals upon the moon's meek shine in even monochrome and curving line of imperturbable serenity. How shall I link such sun-cast symmetry with the torn, troubled form I know as thine? That profile, placid as a brow divine, with continents of moil and misery. And can immense mortality but throw so small a shave, and heaven's high human scheme be hemmed within the coasts yon arc implies? Is such the stellar gauge of earthly show, nation at war with nation, brains that teem, heroes and women fairer than the skies? Thank you, Scotty, and back to you.
Well, thank you, David. Beautiful poetry as always. And, I'm glad you were inspired by those videos. I was looking for a nice series of videos that I thought was inspiring about the moon and, what we're doing as humans. We're getting ready to go back. And, you can count on that, just like Global Star Party, it's going to be an international effort. And, I really do believe we're going to have people living 24/7 on the moon, much like they do right now on the International Space Station. And much like the ISS, it will be people from all over the world and people from all kinds of backgrounds. So I think it's going to be really cool. And, I think that, I hope to be, living to experience it and see it come to fruition, because it really will mark a huge milestone in humanity and may teach us some important lessons back here on Earth. Our next speaker is, we're doing a little bit of change up here. We used to have our door prize section with the Astronomical League kind of just before first break. This time what we're going to do is we're bringing them on up front here because, who doesn't love door prizes and who doesn't love the Astronomical League? Furthermore, who doesn't love Chuck Allen and his the contributions he's given to all of us here on Global Star Party. So it's been really cool. Chuck, I met Chuck, I think it was early 2000s, might have been late 90s. And he was president of the Astronomical League at the time. Chuck can pinpoint it better than I can, but I met him and Bob Gent, and they were so excited about launching something called the National Young Astronomers Award. And, I was happy to be involved in it. Mead Instruments had decided to support it. They sent me to be the, kind of a front man for it on Mead's side anyways. And it was just a huge honor for me to see these young people who were brilliant winning, the National Young Astronomers Award and being recognized for that achievement. It's now been, I think, has it been 2 decades, Chuck?
The first award was 1993.
93, okay.
And I think you became involved.
It's been over 2 decades. So time goes by fast.
Yes.
But what's interesting is how the lives of these young people were influenced by their involvement in science and by their recognition by the Astronomical League. And so to have played a small part of that, because we just agreed to support the award and to offer a prize, and a telescope, but the venerability of it was that it was recognized by the largest federation of astronomy clubs in the world, which is the Astronomical League itself. And so I think that's huge. And so that, the league and the vision of Chuck Allen and Bob Gent at the time, has affected so many people and that are making big contributions today. So, that's my Chuck Allen story for the moment. There's others, but it's all about the inspiration of this man. And so, I'm glad that you're joining us once again on Global Star Party, and we'll let you go ahead and take over the door prize questions and answers.
Sure. First of all, Scott, the reason this program has succeeded for nearly 30 years is because of you. Your early sponsorship and continued sponsorship when we needed a sponsor later on were really critical factors in this award. A lot of the kids who apply for this award also enter the International Science and Engineering Fair and submit to the Intel Science Talent Search as well. And some have won ISEF top awards. So we get really fantastic submissions, and they're impressive as heck to see. So thank you for everything you've done to support the program. And we'll be announcing our winners for this year in about 30 days. So the packages have gone out to our professional astronomers.
Right.
Let me share a screen here, if I may, let's see here. Yeah. Okay. Just 1 second. Okay. I'm showing this picture because of your intro tape, Scott. Many people don't realize that we not only launched Surveyor in the mid-1960s, but we also went and visited it on the Apollo 12 mission. Apollo 12 landed just 600 feet from Surveyor 3, which landed on the moon 1 year after Surveyor 1. And so we just walked over and took the camera back and took some parts off of it to study any micrometeoroid dust that may have settled on the vehicle itself. So it was really an amazing bit of closure there from 1967 to 1969, 2 years later, visiting the vehicle that we landed there. The vehicle itself was testing the surface, by the way, for stability for the landing of the LEM. So the Surveyor spacecraft basically told us many things about the surface in terms of its temperature, its radar reflectivity, and also, again, its stability for purposes of landing a LEM. And it was very helpful in that regard. I want to put in a plug for our virtual convention. This year, we're holding, hopefully, a unique virtual convention for the Astronomical League, and hopefully it'll be the last virtual one. We'd like to get back to live conventions in Albuquerque next year. We've delayed that convention for 2 years. Jocelyn Bell Burnell, Dr. Bell Burnell is joining us from Oxford University. She is, of course, the discoverer of pulsars. We have an amazing series of speakers. We have Dr. Richard Gott from Princeton, Dr. Caitlin Ahrens, Dr. David Levy, who's joining us tonight, my good friend here. We have all of our 2020 and 2021 League Awards, Youth Awards included. We have a SLU presentation, a VLA tour. We'll have our library telescope program discussed, and also the drawings for the 11 library telescopes that we give out each year. We have actually now over $4,000 in door prizes, each one contributed by a club in the Astronomical League, and they're still coming in. So this should be exciting. You do not have to be a league member to attend this convention and be eligible for door prizes. You just have to register. And the registration, again, if I can go back, is right up there, alconvirtual.org. It's www.alconvirtual.org. If you forget that, just go to the Astronomical League website. There's a banner and a link right on the first page. And we hope to see you there. It's August 19th through 21st. Sessions at 3 p.m. and 8 p.m. each evening, Eastern Time. I'll put up our solar warning for those of you who are new to astronomy and maybe tempted to do something by way of solar observing. There are lots of dangers there. I've talked to many people, professional ophthalmologists, about the reaction time of the human brain to seeing something that's too bright. And the fact is that the human brain cannot react faster than your retina can be totally destroyed by sunlight seen through a telescope. So you can't rely on just yanking your head away. It's too late then. So you must learn to be safe in absolute terms when observing the sun. Never observe the sun without professionally made solar filters that have energy rejection filters mounted at the front end of the telescope, not at the eyepiece end. Never use solar filters or welder's glasses that attach only to the eyepiece. They used to make those back in the 60s, and I thought they were crazy because of the heat that would build up inside the eyepiece and inside the telescope. Never leave a telescope or binoculars unattended in daytime, especially if small children are around, because they will try to acquire the sun with it. I've seen it happen. Never use non-certified eclipse glasses or viewing cards unless they comply with ISO 12312-2 international safety standards. And beware that just because it has that ISO certification on them, they could be counterfeit knockoffs. So find a reputable source for the eclipse glasses that you purchase. We order them to sell through the league, but we have them tested after they arrive. So we want to make sure that they're reliable, and there are sources that we can provide you. Never use eclipse glasses or viewing cards to observe the sun while using binoculars or a telescope. They are solely for use in looking up at the sun naked eye. And local astronomy clubs can help you with this. So here are the answers from GSP 45. Our door prize questions are basic questions for general audiences. And here are the answers from about 10 days ago. The Greek mathematician, astronomer, and librarian Eratosthenes is famous for measuring what distance to within 10% accuracy? The answer is the Earth's circumference or diameter. Number 2, which of these is the famous Crab Nebula? It's Messier 1, seen in image A, the upper left. Supernova remnant. And what French comet hunter became famous not for his 13 comet discoveries, but for making a list of objects that might be mistaken for comets? That, of course, is Charles Messier. Created a catalog of 103 bright nebulae, galaxies, and clusters that's now been expanded to 110. The correct answers from 10 days ago were given by these 8 individuals. I won't read them off. I'll just let you read them here. And their names were put into the pool for our May door prizes, which are drawn at the last GSP of each month. So the winners for this month that were drawn were these 3 individuals: Christopher Larson, Jim Hendrickson, and Mark Helton. Congratulations. Okay, here are the questions for tonight. These answers, by the way, will go into the June door prize pool. Number 1, what is the name of the tallest mountain on Mars? And number 2, what is the name of this constellation, sometimes known as the Northern Cross? Note that your answers should be emailed to secretary@astroleague.org, not chat here on the GSP, but emailed to secretary@astroleague.org. And the third and final question for tonight. In 1949, this 200-inch telescope became the largest telescope in the world, a title it held for 27 years. Where is it located? Okay, I'd like to mention that the Astronomical League Live Event 7 will be held here with Scott Roberts' wonderful help on his platform on June 11th of 2021 at 7 p.m. Eastern Time, 6 p.m. Central. This program will feature Haley Wall, a PhD candidate at West Virginia University. She'll be speaking on pulsars. So we hope you'll join us for that as well. Okay, that will do it for tonight, Scott. And again, thank you so much for hosting us again.
Great, thank you so much. Thank you. Okay, thank you, Chuck. I understand Molly Wakeling's in the house, and so Molly, you're up next. I met Molly at the Advanced Imaging Conference for the first time, and I saw Molly. She had just come from, I think it was the Canon booth, and she had this. I've told this story before, but she had this beautiful print she was holding in front of herself of Rho Ophiuchus, and it was beautiful, you know, showing all the colors of that nebular region and everything. And she's talked about the image before, but it's just kind of stuck in my mind. And she had this big beaming smile and stuff, and I just thought it was wonderful. I was able to talk to her for a little while, and you know, since that time, Molly has contributed so much to Global Star Party. She's been on many of our programs. She not only shows up on our programs, but she's also on, she has her own Astronomoly website, and she is on, I guess, many other streaming programs about astrophotography. She's an expert on image processing. She lives in, you know, kind of a suburban environment, maybe an urban environment, actually, I should say, because she's in the Bay Area. Lots of light pollution, but she gets lots of work done. And, you know, it's always a pleasure to have Molly on, you know, not only to share what she knows, but her passion for the night sky and science. So, Molly, I'll turn it over to you.
Hi, I'm glad to be back. And the picture that Scott's talking about is this one here.
I love that image. I love it. Yeah, when you see the real print, it's just like, wow, you know, so yeah.
Yeah,
Very cool.
It's my favorite, one of my favorites. I think pretty much almost my top favorite of all the ones I've done. So, kind of a combination of Scott's and my idea is I'm going to start at these global star parties doing like sort of a mini series highlighting astronomical objects and also like information about them, scientific information, what they are, what you're looking at, stuff like that. So I think part of the observing experience is not only seeing the cool stuff and knowing that you saw something that was far away and was amazing, but also knowing something about it and having some idea of what you're looking at. So we're calling it Astronomy's Universe, and I'm going to do the first one tonight on the Rosette Nebula. So let me share my screen here. All right. Yeah. So this is the image on the right here is my most recent image of the Rosette Nebula, done with my Takahashi and my ZWO-294 camera. I really love with this target. It's one of my favorites. All right. Yeah, there we go. Okay. So what is the Rosette Nebula? It is a type of nebula that it is an emission nebula, or what's also referred to as an H2 region. In the center of the Rosette Nebula, and one of the kind of the primary NGC number associated with the Rosette Nebula, which doesn't really have its own NGC number, but there's a NGC number for the open cluster in the center. There's NGC numbers for some of the brighter regions of nebulosity. So it's got about, I think, 5 or 6 different NGC numbers affiliated with it. But NGC 2244 is that open cluster in the center. And as is the case with, I think, pretty much all emission nebulae / H2 regions, is it is a stellar nursery. New stars are born here from old stellar material that is the gas that you're seeing. So where is the Rosette Nebula? It's in the constellation Monoceros. And if you were to look top down from down onto the Milky Way, here's a map of the kind of our corner of the Milky Way. And these labels are hard to read, so I circled them here. Earth and the solar system is approximately here. And then the Rosette Nebula is back here on the Perseus arm. So just one arm behind us over on the Milky Way, looking outwards from the core, which is why we see it in the wintertime and not in the summertime when we're looking towards the core. Up in the night sky, it's just left of Orion, at least for us Northern Hemisphere folks. I guess it would be on the right for you Southern Hemisphere folks. But to the east of Orion. And so this map here, we have the Orion's belt, and then over to the left is the red patch of the Rosette Nebula. So some fast facts about the Rosette Nebula. Mentions in the constellation Monoceros, which is not a really easily recognizable constellation, and it's that's what is that, Greek for a unicorn. It's the constellation of the unicorn. It's kind of one of the dimmer constellations. It's really dwarfed by Orion. It's about 5,200 light years away and has a diameter of 130 light years. So it's enormous. It's huge. And the apparent magnitude value that I found for it is 9.0, but I'm not sure if that's for the nebula or if that's for the open cluster. Although the open cluster is kind of bright, so it might be for the nebula. But magnitude with nebula is kind of hard to tell because it's sort of the integrated value, and this is rather large on the sky, so can't necessarily compare it with like a magnitude 9 star, for example. And it's the official state astronomical object of Oklahoma as of 2019.
That is awesome that a state would have an official astronomical object, you know.
Yeah, I think that's
great.
I think it's its shape because it looks kind of like that Sooner O on the helmets, if you think about it.
I see.
Okay, yeah. And plus with the red color, yeah, that
might be it.
Yeah, I would believe that for sure. So what causes the red glow in emission and H2 nebulae? So a little bit of science here. The picture over on the right is the kind of a rough map of the electron shell structure of the hydrogen atom. So now the hydrogen atom, it only actually, any given hydrogen atom only has one electron floating around it, but that electron can have various quantized different energies that it can absorb. And we classify these into steps of n equals 1, n equals 2, n equals 3, as you can see on that chart there. And there are several series of energy decays of that electron. So it can be in a higher energy, but as with everything in the universe, it desires to be a lower energy. So it will eventually shed some energy in order to drop to its ground state, its lowest energy state. And it does that by emitting light. And so there's the two series of that shown here are the Lyman series and the Balmer series, where in the Lyman series, it drops from whichever one of those shells back down to the ground state shell, the n equals 1 shell. And the Balmer series is where it drops from any of the higher shells down to the n equals 2 shell. And that's the light that we see visually most often with hydrogen. That n equals 3 to n equals 2 transition right here is that hydrogen alpha light, that characteristic bright red that is seen in so many nebula across the sky that you can't really see with your eye because our eyes are not very sensitive to red in general. And at night, when you're looking through a telescope and it's very dark, you're looking at a very dim thing, the rods in our eyes that are sensitive to light are not sensitive to color. So the red is hard to see. You'll probably more likely see oxygen that's in there and reflection nebula that's in there, kind of all blue. The line you might have heard of is the H beta line, which is this 486 nanometer line dropping from n equals 4 to n equals 2. And 486 nanometers is blue. It's firmly within the blue part of the spectrum. Then there's some higher energy drops as well in a even bluer blue and kind of starting to border into the ultraviolet here for this transition. So looking over on the left, this is what the spectrum of hydrogen looks like in visible light. So visible light, that light that our eyes are sensitive to, spans from 400 nanometers of wavelength to about 700 nanometers ish. And so here's that, it's called H delta, H gamma, or sorry, H delta, H gamma, H beta, and H alpha over here in that deep red. So there's some science for you, a little bit of quantum mechanics.
Cool.
You have been scienced this evening.
Yes.
All right. So hydrogen gas also glows on other wavelengths, as well as other gases that are present in the nebula. If you've ever imaged it in Hubble palette in narrowband, do you know that there's oxygen and sulfur in there as well, in addition to other gases? And those also glow on characteristic colors, oftentimes outside of the visual spectrum. And hydrogen also has several emission lines that are outside the visible spectrum as well. And then of course the stars are glowing in their black body spectra all across wavelengths. So the left image here is a radio image of kind of the whole area. It's got the Horsehead Nebula, the Orion Nebula, Barnard's Loop. It's kind of a familiar shape to people who look at this region a lot. And the Rosette Nebula. That there's a lot of hydrogen around here, and a lot of this is probably hydrogen gas emitting on radio wavelengths. And then further up the electromagnetic spectrum is infrared. So this is a Spitzer image, not of the whole nebula because it's got a pretty small field of view like most space telescopes, but kind of zooming in toward the core. Here's one of the little fingers that you might recognize as kind of one of the fingers that you could see kind of getting into the core if you look at a wider field image of it. But they've got 3 different infrared wavelengths here, up from, what was it, like tens of microns to a couple hundred microns, color coded into these different colors. So you can see different gases glowing at different infrared wavelengths. Other wavelengths include ultraviolet, So you can't really see the rosette shape anymore in ultraviolet. It's kind of got a different profile to it. And then a lot of X-ray and gamma ray surveys tend to not be very high resolution unless they're really focusing in on one area. And I guess the Rosette Nebula is not particularly interesting in X-ray and gamma ray, although I was seeing that there was some papers on X-ray emission from the stars, the hot young stars that are in there. But this is the best survey images I could find in the Aladdin software. So yeah, you can't really see much, but it's been imaged in these wavelengths before as well. All right, so let's dive into some of the features of the Rosette Nebula. So first here, we have this central cavity. So the star cluster NGC 2244 are a lot of these bright stars here, with the exception of, I think, this one, which is actually a foreground star. But the rest of them belong to the open cluster. And these are hot, very hot, young O-type stars that are just blasting out stellar wind. And that stellar wind has carved a cavity inside of the Rosette Nebula. So it's kind of that hole that you're seeing there that makes the sooner O. Now some of the stars in that cluster are 400,000 times brighter than the sun. Like if we were near to it, and 50 or 60 times more massive than the sun. So there's some truly awesome stars in there. And the age of that cluster is on average less than 5 million years, which is pretty young in a star's lifetime compared to our sun, which is 5 billion years old. So 1,000 times older. So yeah, these hot young stars that are blasting out all kinds of radiation and carving the cavity in the center there. And then if we zoom in on one of my favorite sections of it, there are these little dust lanes here with some really cool, intricate detail that you can get if you have good optics and maybe do some deconvolution. And yeah, so this is dark molecular dust that is absorbing at least visible light as it goes through. And infrared light is usually able to see through, or kind of make its way through these dust clouds, because they tend to be a little on the cooler side. But yeah, so this is molecular dust. And also in here, you can see these little globules that are kind of separated from these fingers of dust, and those are called Bok globules. But to give you some perspective on how, I mean, these structures, they look small, but they're actually enormous. Like this finger, for example, is on the order of 10 light years long. Just wow. that finger there. And so like if our solar system was in there, it would be less than like 100th, I think, of the size of that. And that's the whole solar system from like Oort cloud to Oort cloud. So it's just a massive, massive, massive structure. So zooming back out, I wanted to show off another one of my images, of course. So I live in the East Bay, which I live just north of Berkeley. So kind of in the suburban urban transition region. I rate it at about Bortle 7, because I can see a lot more stars than I would expect from being somewhere this bright. So, but yeah, it's still a challenging area to image from. This is with my ZW294 color camera on one of my more recent acquisitions, a Rokinon 135mm f2 lens that I usually run at f2.8. And this is with the CLS-TCD light pollution filter. So this is a wideband image of the Rosette Nebula, and you can kind of see some nebulosity up around it as well, because this whole Monoceros Orion region is just lousy with hydrogen gas. It's everywhere, just everywhere, because it's in the plane of the Milky Way. So there's lots of material there. And this is about 8.5 hours of total exposure time, a whole bunch of 3-minute exposures on my Ioptron SEM 40 mount, which I just got last year. So if you want to observe the Rosette Nebula, here's some observing notes for you. Visual observing, you can see it different parts of really any magnification. You could zoom in on that open cluster that's in the middle. You could look at some of the more detailed regions around the cavity and some of those dark nebula if you're in a dark place. And you could pull out more of the blue glow that's there with a nebula or potentially an O3 filter. I haven't actually seen the Rosette Nebula myself. I'm not usually out at a star party in the wintertime with somebody who has a nice telescope to look through. I don't really actually have a visual observing telescope. So one of these days I'm going to have to do that. Photographically, you probably want to use a wide field of view if you want to get the whole thing. So it's going to be a refractor, a short focal length Newtonian, or a camera lens. I'll do pretty nicely with it. Or you can zoom in.
What's the size of the rosette in degrees?
It's about a degree by a degree. Like kind of like four full moons square.
Wow, huge.
Yeah, it's large in the sky. So you can get it with telescopes and as well as camera lenses, but I wouldn't go too long a focal length. Or you could zoom in on just the core, that central cavity, or some of the dust lanes, or some other detail in there, using a longer focal length scope. And it's a nice target because it's really excellent with a hydrogen alpha filter or one of those multi-band pass filters, narrowband filters for color cameras, but it also is nice in RGB. The image here in the background I actually captured with a DSLR, an unmodified DSLR, back in 2017, inside my first 2 years of doing astrophotography. So it can be done with a wide variety of cameras and telescopes, and it's just a really, really cool object. I've been back to it about 5 times now, and I'll certainly be imaging it again in the future. So with that, does anybody here or on YouTube have any questions?
I just I have observed this nebula visually, and it is spectacular because you have to like scan across, to see the whole thing, unless you're like in some sort of rich field telescope. But it's really diffuse, So I'm interested to get back out under dark skies again and use some filters that I didn't have when I observed it years ago, So, but I think people love your program. They're very excited that you're going to have a series on Global Star Party, and you did a wonderful job. I love it when you drop in science like that. So it's very cool.
Thanks.
I love the overview of the bomber series. That was fantastic. It was nice. It was succinct. It was great.
Yeah.
And I'll be back on at about 6 a.m. Central Time, so 4 a.m. Pacific Time ish, with bags under my eyes and probably a house coat on, to broadcast part of the total lunar eclipse happening early in the morning. That I'll be imaging. So I'll be doing it with my DSLR and using backyard Nikon. So kind of have a chance to see what backyard Nikon looks like for anybody who does DSLR imaging. Highly recommend.
That sounded like you have clear skies.
I will.
Knock on wood. Yay.
Astrospheric is showing a great forecast actually for the whole night. Let's see, let me get this pulled up here.
We are all going to live vicariously through you.
The green screen filter is catching some of lighter blue there.
Oh yeah, look at that.
Top row is the cloud cover, and it's looking very, very promising and not even really too hazy or anything. So
very cool.
Yeah, I compare that to.
You can come watch mine.
Yeah, compare that to Michigan. The visual thing is messing it up, but it's the exact opposite of yours. It's all white. So even if we wanted to see the partial, because I think that's all we would see is partial here in Michigan, we're not going to see anything but the Michigan Nebula. That's what we're going to observe.
Michigan Nebula. That's right.
All night long.
And I will be getting, we are getting all of totality here in California, and all of the partial phase And then the sun will be coming up during the penumbral phase, which is boring anyway. So we'll have all the good stuff.
Oh, good.
All right.
Good for you. We'll get you back in 2024 when we get totality closer to our area. Of course, we hope not to have, the Michigan Nebula to block that too.
Don't jinx it.
No, I'm gonna go down to Texas. Wherever I'm at, I'm gonna drive down to Texas. I'm not messing around.
I'm on the fence. I know that I'm close to the totality an hour away, but so many people, including folks from my own astronomy club in Michigan, are also planning to go to Texas.
Yeah.
And I'm not so sure I don't want to join them. It's a better, especially if the forecast looks better, I may be hopping in the truck and joining you all, because I'd rather see it than not. Even though I've seen it in 2017, I don't see it again. And my kids will probably come with me again.
In 2017, I was in Ohio, and I could have just driven to Kentucky or Tennessee, but it's too cloudy over there most of the time. So I drove to Wyoming, which was really worth it. Although Kentucky and Tennessee both had clear skies.
Yeah, I was in Tennessee, and we had one cloud bank. It moved on out of the way, and it was dead clear when White House, Tennessee, an hour. Now that was an hour from Nashville. In Nashville, that cloud bank covered the eclipse during totality. It was dead clear an hour south where I was, or north, where I was. So we were pretty fortunate to see the entire eclipse.
Hey, Molly, I wanted to thank you for your presentation. I thought it was excellent, invigorating, and very interesting. And also, Chuck, I really enjoyed your presentation as well. And thank you.
Yeah.
And Molly, I have to say the same thing. The science part of that, as well as the art part, somehow you mix science and art in a way that is just awesome. Thank you.
Yeah, spot on. It's great. It's great. Okay. Well, Molly, thanks again. I think we're all energized here. Our next speaker is Kareem Jaffer. Kareem is one of the, I may be messing this up, Kareem, but you are, well, it says right here, you are the Montreal Center Public Events Coordinator for the RESC. You were hosted one of the Global Star Parties for us, and you did an excellent job. Beautiful series of speakers, and so I'm so happy that you've joined us again to share in this 47th Global Star Party. And I will turn this over to you. I hope to. I know that you were in the audience when I was at the RESC event giving a short presentation in person. And I think that I believe that we actually met kind of face to face for a moment there. But Kareem, thanks again for coming on, and I'm looking forward to this presentation.
Oh, my pleasure, Scott. Thanks for having me part of the GSP panel. I'm loving this. We had a lot of fun a couple of weeks ago, well, a week and a half ago on May 15th for International Astronomy Day. And Adrian and you stayed up with us till the early hours of the morning, a good 8-hour marathon GSP. That was a blast. And I was chatting with Scott about some of the ideas of things to add into the GSP. And we decided that since we've been starting our Montreal events with something different than a straightforward land and sky acknowledgement, that I'd bring forward a few of the ancient and indigenous stories and bring them into contact with whatever's happening in the night sky at that time. So tonight, I'm going to talk to you a little bit about what we're doing at the RASC and the RASC Montreal Center. And then I'm going to share with you a few of the stories of the eclipse that you may or may not be aware of, something a little bit further away from the traditional, what we hear about from the Egyptians and the Greek. We're going to go into a few other cultures and a few other stories. And I even have a nice surprise for you at the end. Scott's going to play a video in about 10 minutes with an authentic First Nations Indigenous voice telling us some of the stories of the eclipses from some of the Canadian First Nations. So I hope we'll have a blast with that. But I wanted to start off with something that was left over from International Astronomy Day. And Adrian's here, and he'll remember we were having this discussion about pursuing astronomy in a family, and the need to have kind of a supportive family, supportive wife, supportive husband, a supportive group that wants to do the astronomy with you. So I wanted to just take a moment and acknowledge my wife, because today is our 19th anniversary.
Oh,
and so I wanted to wish her a happy anniversary. And what you can see there in the little slide that I made for her and with my kids is the person who I purported to be at the start in the corner there with, nice, clean shaven, thin and all properly made up. And now the hairy beast that I've become in the other corner with COVID times. But it's been a blast. And my wife and I actually met over discussions about astronomy and her time in Hawaii, getting to be part of the Canadian NSERC Women in Science program and getting to be at the telescopes there. And my jaw dropping in envy and jealousy of never having gotten to actually be at a telescope or own a telescope at that moment in time. And from there to now, where my kids come with us and we do outreach together, and we've gotten a chance to meet Chris Hadfield. We've gotten to do the Apollo 11 50th together at the Aga Khan Museum in Toronto. And it's just been amazing to have a partner with me through this journey. And this journey that we're doing at the RASC and the RASC Montreal Center is full of amazing programs. So at the International Astronomy Day, I mentioned this new program that we were launching, which is called Creation Station. And it's basically calling out to kids ages 5 to 12 and giving them a space to just run away with their imagination about astronomy and space. And we've started to receive the first few submissions, and my jaws are dropping again, because seeing the stories these kids want to tell and the imagination that they're putting into their comics and their short stories. And there's one kid who submitted a short story where he had so much to say, he just kept going and going, no punctuation, just thought after thought after thought. And I was left breathless just reading all of this, and it's fantastic. The other things that we're doing with the RASC is we are just finishing up our Moon at Noon series, which is our Thursdays at noon on YouTube. If you look for the RASC Canada YouTube channel, our last 4 classes are coming up starting this Thursday at noon, but they're all cached. So if you want to explore the moon, if you want to learn what targets you can look for during different days of the moon's cycle, this is a great chance to really get out your binocular, get out your small telescope, and really learn about the moon. And then we're working really hard to prepare for our General Assembly, which is coming up June 25th to 28th. And I was talking to Chuck about the virtual astronomy assemblies and trying to do them with the large groups. And it's a lot of fun. And I'm happy to say my daughter is actually giving one of the workshops for the youth on June 25th. She's 13 and she's giving a workshop on drawing alien life forms and learning about extremophiles. And so, like I said, it's kind of fun to be doing this as a family. At the RASC, we have our public events and our members events in our Montreal Center. And our next public event, everybody is welcome to attend. It's actually going to be a fantastic educational opportunity to learn about the fusing of art and astrobiology. And the specific research project is by Bettina Forget, who is the art director for the Artist in Residence program at SETI. She's also an educational researcher here in Montreal, and her research is into encouraging girls into STEM. So we're doing this as kind of a meeting format rather than a webinar format, so that we can hear from Bettina, her project goals and the things that she's doing in fusing art and astrobiology, and then just open it up to a discussion amongst all the participants. So you're welcome to attend, and the link to register is there, and you can always find our information on our website. And then our center itself does clubhouses twice a week. And this was the thing that Scott and I were chatting about at the start, where he couldn't believe that all through COVID, we have continued to meet twice a week, despite lockdown, despite curfew, despite not being able to get out and actually do astronomy ourselves sometimes. We don't run out of things to talk about because there's so much happening in space and in astronomy. So the next couple of clubhouses, we have an intro to the June night sky. We have Whirlpools in the Sky on June 2nd by Peter Williamson of the UK, who some of you got to see during GSP 45. And he's going to talk about the Leviathan telescope in Birr Castle in Ireland. And then on June 9th, to preface the annular solar eclipse that we're going to talk about in a few minutes, we're going to be showing a viewing of a documentary made by a couple of our members for Chasing Totality in 2017. And the information's there to join our center if you're interested. But what I really want to talk to you about tonight is indigenous astronomy and ancient astronomy and how we see the things in our night sky. And tonight's full moon is not just a blood moon because it's a lunar eclipse. It's a full moon in springtime and the last full moon of the spring. And this full moon by the Cree of North America is referred to as the frog moon, because if you go out at night, you'll hear that the frogs are becoming active in ponds and swamps, and you can hear their calls straight through the night. But other tribes call it by the planting moon, because this is when fields are plowed and sown because they're now wet enough. They have enough moisture that they can really allow for the fall crops to be able to nourish themselves through the summer and grow. And in European culture, it's called the corn planting moon, partly for that same reason, or the full flowering moon, because again, we have tons of amazing flowers out in our gardens these days, if you've managed to get a little bit of rain, a little bit of sun, and a little bit of clouds. There's also a really high KP warning coming up because of the geomagnetic activity of the sun over the last few days. And so tonight and tomorrow night, we're actually expecting a geomagnetic storm. And so I wanted to mention with the aurorae, our local planetarium has this fantastic show about the aurora and the way it's seen by the Inuit up north. And it's referred to as Wawate or Wawastu. And it's the dancing spirits of the ancestors. And the idea is that your ancestors are celebrating life. And that dancing is the dancing lights that you see in the night sky. And so it's really an occasion for celebration. And that's a stark contrast with the way eclipses were seen by both the First Nations as well as by a lot of the ancient cultures. Because while the aurora are seen as celebrating life, lunar eclipses are often seen as evil omens. Solar eclipses, it's a mixed bag. Sometimes they're seen as evil omens, or sometimes, such as in Chinese culture, they're actually seen as portents for a strong leadership or a strong transition into a new era of governance, or in that case, it was actually of tribal leadership. So when we're talking about eclipses, one of the areas that I'm really drawn to is the Dresden Codex for the Mayans, but I'm actually going to talk about that in a few minutes. First, I'm going to start with the Babylonians, because when we look at the cycle of eclipses, the Saros cycle, it's first credited to the Babylonian astronomers as having identified the roughly 6,585 days between the sun, earth, moon geometry repeating itself almost identically every 6,585 days. And it's important to recognize that this doesn't mean that the solar eclipse will happen at the exact same location during the next Saros cycle, because of the slight difference between the synodic month of the moon and the actual orbital path of the Earth around the sun. It turns out that the almost identical locations for solar eclipses repeat every 3 Saros cycles. So you're looking at over 18,000 days before the same location has the same type of solar eclipse. Now, the Babylonians were not a traveling group. So how did they actually identify this type of a cycle when it wouldn't have occurred in the same location every 6,585 days? And that's because the solar eclipse is linked directly to the lunar eclipse. They happen 2 weeks apart almost always, because when the geometry lines up, not only will the Earth find that the moon's shadow falls on some area of the Earth, but the Earth's shadow will cover the moon or part of the moon during the full moon phase, just like the solar eclipses will happen during the new moon phase. So what the Babylonians did is they used the observations of the lunar eclipses to predict the solar eclipses by seeing that the geometry had to follow the same cycle, even though they didn't have a model of the universe exactly to say how the Earth, Moon, Sun were aligned with the other planets like Venus that they would spend time watching in the night sky. Now, this is where we really see kind of the rich power of astronomy, or as it was called at that time, astrology. Because if you could predict solar eclipses, you could really have a power over the populace.
Yeah.
And in China, they really were trying to use that. And if the astrologers were slightly off, it made the king look very bad. And so there's the tale of Ho and He. who were two Chinese astrologers who were actually beheaded because they got the day of the solar eclipse wrong by 3 days. So the poem that I found was actually this one that's written it's translated from Chinese, and it's dating back almost 4,000 years now. Here lie the bodies of Ho and He, whose fate though sad is risible, being slain because they could not spy the eclipse which was invisible. Now, the Chinese viewed the eclipse of the sun as the sun being eaten. And then it took the leader at the time to ask for the sun to be released. And so the Chinese term for eclipse is actually the same as their term for to eat, because they really did see it as being gobbled up. And so did most of the indigenous and ancient astronomy at the time, and that includes the Mayans. And so the Mayans saw it as a giant snake, which actually represents a lot of their solar astronomy, as eating the sun and then letting it go. But the neat thing about the Mayan astronomy is not only did they identify the eclipses very well, almost to the same cycle that the Babylonians did, and it was used to predict an eclipse in the late 20th century, but they also always show the lunar eclipse and the solar eclipse side by side in the Dresden Codex. So they saw and they knew that both of these phenomena happened together. So when we're looking at our lunar eclipse tonight, it means 2 weeks from now we have a solar eclipse. And the annular solar eclipse will be visible through a large swath of Canada, either full annular or partial annular solar eclipse, and even in some parts of the northern US. Our RASC Facebook page has some videos talking about the eclipse path and how to safely view the eclipse. And I'll remind people what Chuck said earlier, sunglasses are not enough. You have to make sure you have proper solar viewing equipment if you want to look at the sun. But our friends at Discover the Universe have actually put together an eclipse challenge to safely view the solar eclipse by using a projection method. And so there's a short video invitation. You can always visit their website, discovertheuniverse.ca. And they've worked in conjunction with the Dunlap Institute and the CFHT in Hawaii to get one of our resident indigenous astrophysicists who's working down there at the CFHT to put together a small story or a small video about a couple of the indigenous stories of the eclipse. I'm going to pass it over to Scott to share those stories with you now.
Okay. All right. So let me share my screen here. And let's see. That should do it. And here we go.
There's a very special event coming up on June 10th, a solar eclipse. I am super excited, even though I won't be able to see it from here in Hawaii. Many people in Canada, you, my family, my friends, will be able to see either a total or a partial eclipse of the sun. And this is super rare. Hi, my name is Laurie Rousseau-Neptune. I am a member of the Pequot-Kamilnoets Nation in Quebec and an astronomer working in Hawaii at the Canada-France Hawaii Telescope. Solar eclipses. So many communities around the world are sharing tales about these phenomena. And today I want to share with you 2 stories that are from Canada that I adapted especially for this occasion. The first one comes from the Inuit territory. In a time when darkness covered the earth, Melina and her brother Anengen lived in a village. Using the darkness to hide, someone was disturbing Melina at night. One night, with the hope of finding out who it was, Melina spread dirty black roots all over the mystery face. Using a lamp, she looked at everyone's face to find out that her brother was the culprit. Very mad, she grabbed a brand from the fire and started chasing him. Anengan ran into the sky and Melina flew after him. He then transformed into the moon and Melina with the fiery brand into the sun. During the pursuit, sparks got spread around from the brand and became the stars. They have now chased each other in the sky for immemorial time. Anengan often forgets to eat, and so he gets thinner and thinner as days go by. Every month, the moon disappears for a few days while Anengan eats. Then the chase continues. This eternal cycle makes the sun alternate in the sky with the moon. When there's a solar eclipse, Anangan has caught up with Melina, and Melina is known to be the goddess of the sun, while Anangan, the god of the moon for the Inuit people. Now, the second story comes from multiple communities in Canada, from the East Coast and Central Canada, including the Innu, the Ojibwe, the Cree, and others. And it goes as, in the old days, people were not the chiefs and did not hunt animals. Animals were the chief and hunted people. They killed everyone except one girl and her little brother. The boy learned to hunt snowbird and squirrels with a bow and arrow. He became such a good hunter that he started catching bigger prey. And one day, he felt like something was following him. His sister helped him fashion a snare, and he set it along a melted path in the snow. It was the sun's path. As the sun rose, he got caught into the snare, and darkness followed. The animals were afraid but amazed by the boy. They sent the biggest and most fearsome animal to try to free the sun. The caribou and the moose went first, but it was too hot. The hunting birds flew, but the fire burned their feather. It was a tiny mouse, who in those days was as big as a mountain, that chewed through the snare, freeing the sun. But meanwhile, the intense heat shrunk him down to his present size. Since that time, the people have been hunting on the land, and the sun and the moon follow their cycle. That little boy is Sakapish, and he's known as the man on the moon. This story is actually tightly related to annular eclipses, during which you still see a line of light around the moon, that snare, and the moon is Sakapish, who's catching it. So we can now predict when solar eclipse happens. So be prepared and have your solar filters. And oh, don't forget to put your alarm clock super early on June 10 and catch the solar eclipse.
So thank you to Lori. Thank you to the Discover the Universe and Dunlop Institute. And thank you, everyone. I hope you enjoyed these brief glimpses into the ancient and indigenous stories of the eclipses.
Yeah, I think it was wonderful. It was wonderful. Our Corinne, thank you so much. That brings a whole new dimension to Global Star Party. You know, these stories and the lore, and you know, of course, it's all intertwined with the development of all of humanity and where we are today. You know, so I think it's important to understand these ancient stories and with the indigenous of the world. So I've always found it fascinating as I've traveled to try to dig in and find out more about how they viewed our universe, you know. Our next speaker is Jerry Hubble. Jerry and I met initially at the Northeast Astronomy Forum. I guess it's been now over 10 years.
It's been, it was in 2010, I believe, when we first met. Mm-hmm.
Yeah. And so it was great. I was really impressed with Jerry and his knowledge of astronomy and hearing about his background. And it was not too long thereafter I had challenged him to create what is now called the PMC-8 go-to system, which is now being used around the world and is supported by something called the Open Go-To community. So we have amateur astronomers truly driving the technology and the direction of what go-to technology is. I did, having come from another company that always wanted to kind of dictate what robotic amateur astronomy was all about. I wanted the community to kind of lead the way and eventually, take over the interface of how that works. And so we have seen several important steps in that direction. And it seems as time goes on, that whole community contribution is getting stronger and stronger. So, yes. Because I believe that go-to robotic astronomy is part and parcel with what amateur astronomy is today. And And that should be driven by the community and not by any one company, for example. So I'll get off my soapbox about that.
No, that's good.
Jerry knows that quite well,
yeah.
So it's been an honor to work with Jerry. He's a devoted amateur astronomer. He's done tons of outreach. He's been on a lot of these programs. He started these live broadcasts with me, and he's still doing them now in a show called the Open Go-To Community Live. So thank you, Jerry.
Thank you, Scott. I appreciate it. And we're lucky tonight to also have I consider him a pioneer in robotic technology, and it's Bob Denny.
That's right.
Who started the ASCOM project for telescope control. So, and I take full advantage of that system that he developed for everybody with the PMC-8. So it's great. So tonight I'm going to be talking not about the technology so much, although I will be mentioning some new technology but I'm going to be talking about the work that I've done observing exoplanets, transits. And I gave this talk actually a couple times. I'm going to be giving us a short version of the talk that I gave at the NEAF and at the, I think this is one I actually gave last year at the AAS. And it's based on a paper that we wrote at the Mark Slade Remote Observatory, where I do this work. And the Mark Slade Remote Observatory was founded about 5 years ago. This is the paper. And what I'm going to be talking about is a specific technique that was developed at University in Pennsylvania and other places that I found their paper, and then adapted their technique to small telescope systems using the same equipment. So I'll be talking about this specific method that they developed, and I've been able to adapt, I think, successfully to small telescopes. I'm gonna share another screen here. If I can find the right presentation. Let me go back to my, I don't know if you guys have seen my desktop before, but I got hundreds of icons along the top and bottom. I have a tendency to keep a lot of stuff open. Is really to make it handy for me. Sometimes it's hard to see where it's at sometimes, but here's the presentation. Can you see that?
Yes.
All right, so I'm going to be talking about the high precision photometry used to do measurements for exoplanet transits, and these are transits that are very small changes in the light in terms of the brightness of the star. So in a transit, I'll get into this, but a transit basically is like a Venus transit that we see from Earth, where Venus crosses the face of the sun. That's basically the same geometry that's going on here. Just a little bit about myself. I'm a retired Dominion Energy Nuclear Instrumentation Controls engineer, and I'm the vice president of engineering for Explore Scientific, as Scott said. I'm also the vice president of MSRO Science, which runs the observatory and owns the observatory. And finally, I wrote these two books that you may or may not seen, but they're available on Amazon and on Springer Books. So this is the paper that we wrote that was published by the Society for Astronomical Sciences in June 2019. And here's the link for it. And so if you go to archive, you'll find it there. I've got a slide at the end that has some information for everybody also. But basically, this is what the Mark Slade Remote Observatory Station 1 looks like inside this dome. And the director is Dr. Myron Wasuda on the right there, and I'm on the left as the assistant director of the observatory. Our main instrument is this 165 FPL53 APO that's Explore Scientific flagship. I call it the flagship telescope because it's our largest refractor that we have available. It's an excellent telescope, And then we also have a secondary telescope on the system. That's an ES-102. So to get into the main meat of this talk, there's two different ways to measure the brightness of the star that we use in this method. One is, and they both basically spread the light out of the star. And the reason we want to spread the light out is to make as many pixels as we can to gather the data without overexposing any of the pixels. We want to be able to gather the light over as many sensors as we can so that we have a high number of photons that we collect. The higher number of photons you collect, the lower the shot noise is what it is. And shot noise is basically a random error that you get whenever you measure radiation. It's just the randomness. It's a statistical number, and so in order to minimize that, which if you've got a focused star, you've got like the light of a star over like maybe 5 or 10 pixels, you're going to have a lot of noise in that signal compared to when you spread the light out. And that's really the goal, is to minimize that type of noise in the measurement. Now there's other types of noise that are still remaining, but this is the first cut at getting the noise level down, so that because the brightness changes we're talking about are less than about 1% or less changes in the brightness. So that's what we're going after. So on the left there, this shows you what a diffused image looks like compared to a defocused image. They're very similar, except we use a special instrument called a diffuser to obtain the diffused image, and it creates a profile or a point spread function that's different than a normal star. So this is kind of the difference. So in a defocused or a normal star image, you've got a point spread function that looks like a Gaussian shape, like there on the right, okay? But on the diffused image, the profile looks like it's called a top hat profile, where you have steep sides and you have a flat top. So basically you get all the light within this area gathered, and you never overexpose because it's spread out further. So you can take a long exposure on even a brighter star and you will not overexpose the data. And that's an important thing too, because you want to be able to count the photons accurately, so you don't want to overexpose the image. So this diffuser creates this profile of the star, where a defocused normal star image looks like the Gaussian shape on the right. And the device we use is called the Engineered Diffuser, and it's created by a company called RPC Photonics that's based in New York. And you can see here on this picture on the left, where I'm holding it, it looks like a frosted glass kind, and you can see it on the right-hand side too, right there. It kind of looks like a frosted glass, but it's actually kind of like a like these little tiny dimples on a plate that spread the light out in a certain pattern and come together. And again, this is what a star image looks like. You can see there's different angles. So when you get a different angle diffuser, it spreads the light out at different sizes, and there's a calculation involved on how big it would be on your plate, on your CCD chip or your CMOS chip. And so this is what the star image looks like when you expose it. You can see it's kind of like a cool starburst image. It's kind of neat looking at it with the diffuser. It's different than what it looks like with the focused star. One of the main things, I don't know if I talk about this on the next slide. One of the main things that this diffuser does also is it takes the light from the star and basically mitigates or settles out all the scintillation in the star. So the star could be moving around as it comes in, you know, like you normally see when the seeing is noisy. And you see, if you took a video of the starlight, or if you look at it with your eyeball, you can see it twinkling. That's seeing. You can see it moving around on the chip also. But the way the diffuser is designed, it spreads the light out into this pattern, but it also averages out all the seeing. So the scintillation basically disappears. It's a steady glow, a steady profile, so the scintillation is another source of the noise that you mitigate or you reduce significantly with using the diffuser. So those two things together help you to measure the brightness of the star very precisely and look for these small little dips, which is a transit. So that's basically how the instrument works. Now, we started doing exoplanet light curve measurements back in 2018. And we started out, and this was before I discovered the diffuser instrument. This was our first exoplanet light curve that we measured. Bart Ballard, Dr. Bart Ballard is a member of the MSRO team. Him and I both worked on this measurement, or these measurements. And you can see we detected the dip of HAT P30, WASP 51 Bravo. That exoplanet had been discovered probably quite a few years previous to this. And we were just doing a follow-up observation and learning our techniques on how to measure the transits. Now, one of the things you do, you model the light curve, you fit it to a model, and then you can determine some parameters, such as the size of the planet, basically the what's it called? I can't remember the term now. It's the let me move forward here. The orbital inclination. I'm sorry, the orbital inclination of the star. So you can see it's inclined on this model on the right-hand side. This shows you the catalog model on the left here that I'm circling, and then this is our measurement. And you can see it's pretty close. The inclination measurement was very, very precise and accurate, somewhat accurate. And the size of the planet that we measured was also pretty close. So we were very pleased with this measurement. Even though you can see the scatter in the measurement was quite a bit, we were able to model it fairly well. Now, we also, later on, when I discovered the diffuser and put that to work, you can see the difference in the measurement with the diffuser, with the high precision that's available. You can see the noise in this previous measurement, which is the defocus method. And these were made with the same telescope and the same camera. You can see the scatter in the defocus method. And then when we go to the diffuser method, you can see how tight the data is, okay, to the model. And so the depth measurement, there's the noise source for the shot noise or the Poisson noise is down to 1 millimag, or 1/1000th of a magnitude noise, which is very, very tight. And the total precision of the model, the measurement with the scintillation and the shot noise, was 2.7 millimag. And this is a 12.9 magnitude star. No, I'm sorry. The depth that we measured was 12.9 millimag. That's the depth. So we were able to do a precision measurement of the depth because we were able to reduce the noise down to that 2.7 millimag value. So that allows us to do a better model of the system. And the results of that are here. These are the catalog values for these different parameters, and this is our measured value. So the size of the planet that we measured on that HAT P16b was 1.19 times the size of Jupiter. The catalog value is 1.29 size, so it was pretty close. The orbital inclination was very close. It was within the error bounds of the catalog value. It was 86.3 compared to 86.6. Our transit depth was pretty good. As you can see there, 10.76 versus 11.47. And our midpoint time. So the midpoint time value is very important to determine the orbital period of the planet, and to be able to predict the next time it transits. So it's, if you can repeat that measurement and very closely, then you get a good model also. And then the transit lengths, our lengths, the time of between ingress and egress was 2 hours and 4 minutes and 28 seconds, and the catalog time, or the catalog value, was 2 hours and 7 minutes. So that's very close. So those are the results that we got with the diffuser. Now, we've also formed a team at the Mark Slade Remote Observatory called the MSRO ExoFOP team, which is the exoplanet follow-up program for the MSRO. And since August, well, back in August in 2019, we did a bunch of training sessions to get our observers up to speed on the methodology that you have to use to do this work. And then in November of 2019, we successfully observed and verified this TOI as a member of the TESS follow-up team, SG1 group. So the SG1 group is a seeing limited team. So basically from the ground, if you minimize your error terms in terms of the statistical shot noise and other terms in your instruments, then all you're left with is the scintillation limit, basically, for your measurement. And that's why it's called the seeing limited group, because that's, if you got instruments that are that good, then you're basically limited by the seeing on the ground. And at that point, you can do some good work. That's about all I had to cover. I wanted to just go a quick overview of what we do at the MSR in terms of exoplanets. I'll leave this screen up for a little bit. So these are the links that you can go to see more about what we do at the Mark Slade Remote Observatory and at our MSRO Science. So that's it. Are there any questions on the audience?
I don't see any questions here. I mean, people are commenting on that, people are saying it's not art, it's science, here.
Right.
But there's, there is the art of the skill of conducting, or collecting data and presenting science, and you guys do it really, really well. And, I'm excited that, we at Explore Scientific played a small role in that, in helping to get it off the ground. So I think it's great what you guys have done at MSRO. I think you make it exciting for a lot of amateur astronomers who want to actually learn the scientific method. And how many people have you had go through your program so far?
Well, we've got two. I think Myron's got 3 active students from around the world. We've had several people from around the world use our systems remotely. It's a completely robotic telescope system.
Yeah.
And it's pretty reliable now. It took the first few months, of course, after we built it, to get it up to speed and get it commissioned and reliable. But it's been a good 5 years now since we've been using it. And we've changed the instruments out a few times. We've had some failures that we've had to recover from in terms of the mount systems early on. But right now we've got the Explore Scientific equipment in Station 1. We've got other equipment in 2 other stations that we have available to train on and to use for science. Myron's been doing a lot of good work with the spectroscopy with 2 or 3 students, and then a couple other people also around the world. So we've probably we've had local students, 3 local students, probably a total of 10 to 15 people have been using the system over the last 4 or 5 years that are outside the MSRO team. We've got 5 people that are active at MSRO that are on the team, and the MSRO Science work for us. So, but overall, it's been good. We have been able to observe in 2017. We were able to observe pretty much on every clear night. And we had a lot of clear nights in 2017 compared to what we've had over the last couple of years. We observed over 200 nights. Now, we also observe when it's not perfectly clear. We observe when it's partly cloudy because it's available to do work.
Sure.
And it's a manual. The other thing, it's not a fully automated system like what Bob Denny creates. It's a teaching system, so it's a hands-on laboratory basically for people to learn how to observe the sky with these telescope systems and remotely do it. So we teach people how to use the system, all about the equipment, and we hold sessions as often as we can, observing sessions and teaching sessions at night and during the day. So
here's a nice comment here. That's a new school process. I had considered an old school using electron devices and photomultipliers to measure the subtle variations. Well done, Jerry. That was from Martin Eastburn.
Oh, yes, thank you.
Yeah, and so you know, I really admire what you guys are doing, and you know, and to get involved, Jerry, how do they join the MSRO? What's
yeah? So let me real quick bring up the website, and I'll share it here real quick.
I have to say, using this diffuser method is really interesting because the scatter and the uncertainty in your data otherwise is really, it's what my students are finding when they're doing the transit with our RASC robotic telescope, is there's a lot of scatter. And so I definitely want to follow up with you on this diffuser method because it sounds like it would really it would plateau out a lot of the shot noise, and I like
absolutely that. And it really mitigates some of the scintillation too. If you find my paper on archive, then I'll put the link in the
you
chat.
had an article published. It was in Astronomy Magazine. Is that correct?
Right. Last year, Astronomy Magazine also published an article I wrote.
That I probably have it in my library. I just have to grab it.
That's pretty cool. Yeah, was it June? I think it was a June issue in 2020. So this is and you notice what object I have here. This is a picture I took. I'm not a deep sky photographer by any means.
Nice image.
It's Oklahoma's favorite deep sky object.
That's right. So
your official deep sky object.
That's right. So
always Rosette.
That's right. So if you go to msroscience.org, you'll find what we do here and the contact information. So we do outreach, training, and research. And this is what the observatory looks like. And you notice there's a bunch of trees next to it, which is to the north. It's kind of a pain. Our sky is not the best in terms of coverage, but we get by pretty well. We do a lot of work. We have two other stations that I don't have a picture of right here, but this is Dr. Wasuda Myron, a good friend of mine. We've known each other for quite a few years. And then we've got Shannon Morgan, who's a member of our team. She's been a professional trained astronomer. Lauren Lennon is also a professionally trained astronomer. We're really lucky where we're located in Northern Virginia, that we've got access to this caliber of people that want to join us. Dr. Barton Ballard was a retired physicist and worked for the Navy at the Dahlgren Naval Surface Weapons Laboratory. He's an optical physicist. And then Linda Ballard's his wife. And then we got Glenn Faney, who's the president of the Rappahannock Astronomy Club. And then Matt Scott, you know Matt Scott.
Right.
He's our mechanical engineer that does a lot of work for us also.
Yep. Excellent.
And so.
Yeah, an excellent team. Really.
Yes, yeah, we do.
I have a question for you, Jerry.
Mm-hmm.
So I've tried defocusing, or rather using photometry images that happens to be defocused when my focuser wasn't working as well as it could.
Yeah, right.
For my photometry that I do for AAVSO. And I have trouble registering those frames because they're defocused. The registration algorithm in PixInsight, for example, doesn't like that. So what do you use to register those frames?
Well, so it's yeah, depending on how diffuse the star is, a plate solve doesn't work. You also diffuse, I call it diffusing out the stars. So you minimize the number, you start to minimize the number of stars that are available. So you have to strike a balance basically. And that's a big thing that you have to think about using the diffuser also. Okay. And so you take longer exposures. You you never want to overexpose the data. So you have to balance that, and depending on the size of your star, and what comparison stars you have and all that. Your exposure time. But in terms of registering it, I would try to just work with the program, whatever you're using, and make it as small as you can to get away, or make it as large as you can and get away with plate solving if you want to do a good registration.
Can I stick something in here?
Sure.
If you guys can send me some, data, I might be able to adapt pinpoint to be able to deal with those diffuse star profiles as opposed to using a PSF fit or whatever.
Right.
There's 5 different, 5 different object detection and centroiding algorithms inside pinpoint, and they're all hands off. They just run over the image and do it, but you have to select whichever one it is.
Oh, okay.
And if I could get some of those images, I might be able to adjust it so that it would work with that also. And as you'll see after the break, I'm just getting ready to release a V7 of pinpoint, and I'd love to put that in there.
That'd be awesome.
I knew nothing about this until tonight.
Oh, well, great. So I've used pinpoint for a long time. We've known each other for a while, Bob, and I've used pinpoint from the beginning. So that's great.
Yeah, I'll look at it, but let's hook up afterwards. I'll give you a drop where you can put like 10 images or 20 images or something. And that's what I would use to put a set of test images and try and adapt to it.
Okay. Molly, do you have some diffused images you want to send out? I mean, not diffused, but defocused. I've got some defocused images too that I'll send.
I have a bunch of defocused images, and they all have as you said, the PSF shape to the stars. And Pinpoint already has a PSF adaptive centroider, so it's no problem for defocused images.
Okay.
Diffused ones that you showed, and those were Maxim DL graphs that I could immediately recognize. They're totally different than what I've seen. So I'm most interested in getting that data before I release Pinpoint 7 to try to do something about that.
Well, it might actually, because I was thinking too, when you start to, like if you defocus a lot, then you can see the donut shape when you're using a reflector.
Right.
And even if you're just a little bit defocused, that shape is probably there. I haven't looked at the PSFs myself, but that shape is probably there too. So it might help also folks like being able to handle kind of more of that flat top type data, or where it dips a little, might help.
Right. So that was one thing. We worked with Dennis Conti was part of this paper and part of this study that we did. He's a VSO chief for exoplanet observing. And but we noticed a difference. I mean, believe it or not, the Schmidt-Cassegrain type or a reflector type telescope with a central obstruction is really not as good to do the measurement as it is with a refractor, of course, because you don't have that defect in the image.
Yeah, I believe that.
And that defect, you can work around it at some level, but again, it's not quite as precise as what you get with a refractor. So that's why I use a refractor to do this work. And that's discussed in my paper. That's discussed in the paper also.
Sorry, our science people, they try to stay away from Schmidt-Cass with that donut shape if they defocus, because it's really difficult to get precise observations or measurements of the centroid with that. Really tough.
So I'm going to post this link right now on archive to the chat, so everybody will have it to the paper. And yeah, I welcome any questions. Just anybody has any questions at all, email me at jrh@explorescientific.com. and I guess I can put that on in the chat also, and then you can send it out to anybody, right, Scott.
Now. Yeah. Excellent. Okay. Well, I think we're about ready for a 10-minute break. So now it's time to get up and stretch your legs, maybe grab a sandwich, a hot coffee, or something like that. We've got a long night ahead of us. Maybe some of us will take a short nap and wake back up in advance of this total lunar eclipse that's coming up. But will you sleep tonight, Molly, or are you just gonna?
Oh yeah, I'm setting up the rig to run semi-autonomously. But I am going to get up a little before 4 to make sure that it's still pointing at the moon, because my star adventurer doesn't track the greatest. And also to come on and live stream for a little bit. So
yeah, very cool.
4 a.m. my time ish.
Right.
Molly, do you have
6 Central?
But I'm going to go to bed. So.
Yeah.
We will come on earlier. We're going to start broadcasting about 4:30 a.m. Central. Which would be much earlier for you. But we may have people that can log in and start to show different parts of the eclipse as it goes along. Otherwise, maybe I can do some shadow tricks or something like that until we get to Molly. But anyways, it'll be a lot of fun, and I look forward to it. So, okay, so let's make sure I do this correctly. We are going to our first intermission. So thanks for all these great presentations so far, and we will be right back in about 10.
So Molly, do you have any guiding on your star adventure, or you just let it go?
So it'll guide in right ascension, but I can't ever really get the polar alignment to be really good. I think my polar scope isn't quite calibrated. So and I've tried it with Sharp Cap's polar alignment as well, and still haven't gotten a satisfactory result. So even though it guides in RA, it drifts enough in DEC that it gives me a little bit longer exposures when I do deep sky, but I'm not going to bother guiding for the eclipse.
Yeah, so it's a star adventure. I mean, I've taken mine out, the little star adventure. I've done the best I can. I have the older model, so I manually polar align by looking through. And there are nights where, because I'm doing wide angle, nightscapes, astrophotography, there are nights that I can tell that I got it spot on a little, better than others, because I can take longer exposures and the stars stay round. And then if I see that, I put on a bigger lens and I go shoot for something, try to do a little camera DSLR deep space. So it's it's hit or miss. If I'm getting star trails after 30 seconds, and then I start stomping up and down and going, what am I doing wrong? Try again. Yeah. That's when the clouds usually cover the North Star. And, then things get thrown into the lake, and it's not as good a night, but that happens.
You have the lucky to have the polar star in the north.
Yes,
it's easy to find it. Here in the south, it's very difficult.
Yeah, turn right at Crux, right?
It's near, but we have the 4 stars, very tiny and very the magnitude is very few. So you don't have to, with light pollution in the city, it's very difficult. You have to go to the farm, and when you are in the farm or outside the town, there's a lot of stars that you can find it. And also there's 3 stars that matches the asterisk, like the octans asterisk. So when you put it together, you say, okay, I'm aligned, but
I'm close.
Yes,
so then you try your first You try your
when
first image and it trails after 15 seconds.
Exactly.
Then you have to do it
what
again.
I did wrong. Anybody talks about that. Everyone says find the octans asterisk, the 4 stars, and that's it. Obviously, the finder polar has to be very aligned, but it's very difficult. I remember with my brother when I bought the Star Adventurer a few years ago. We were so excited to prepare it, to unbox it, everything. And when we want to find the asterisks in my city, the light pollution or the very light pollution is in the south. So I was with my binoculars and the laser point to find it and tell my brother, hey, bro, there is it. Find it.
Good luck.
Yes.
Yeah, Alan Mari, who I think we've had on here before. He's in Chile, and I stayed at his observatory hotel thing that he's got down there in outside San Pedro de Atacama. And I had to enlist his help to align my Star Adventurer. He was really good at it, though. He took a green laser pointer, kind of held it on the top, and got it roughly pointed. And then just kind of he could do it in like 30 seconds. Like, he was so experienced at it. I don't know how he did it.
Yeah, so obviously I'm gonna need to find some place dark, because if I get frustrated, it's gonna be back to 20 seconds wide angle.
Yeah,
regular.
There's an easy trick to do.
Give up. Yeah.
Can you guys hear me?
Yeah, we can hear you, Simon.
Hi, Simon.
There's an easier trick to do polar alignment, regardless if you can see the North Star or not, and it's by looking at your geographical location. So a lot of people don't realize this, but your lat long tells you where to actually move and how much to tilt the Star Adventurer by. So if I'm here in California, Los Angeles specifically, my latitude is 34 degrees. So if the Star Adventurer is at 34 degrees, it is actually looking right at Polaris. And then I use a compass and I point everything so it faces true north, not magnetic north. And if I look through my polar scope, I'll find that I'm actually very, very incredibly close to it. So if I actually had a digital measurement of some description, you can actually get it dead on without seeing Polaris ever.
I mean, that's how I usually, I'll do that before it gets dark and then fine tune it once it gets dark. And it will get you pretty close. But even when I have Polaris somewhere inside of the 1 degree ring that's in the polar scope, even if it's not dead on, I'm still pretty limited to about 30 or 60 second exposures at 135 millimeters.
Right.
So it'll get you close, but not close
but
enough.
that can be attributed to if you're. I don't want to get too technical for people who are listening.
This is the perfect place to get technical, Simon. But, go for it.
Well, the people who are listening might not understand this, but if your actual imaging camera is not orthogonal with your polar scope when you're doing the alignment to begin with, for polar alignment, this is specifically, what you'll find here is, let's just say this is all facing Polaris and the camera is ever so slightly skewed off in the wrong direction. And then what happens here is you don't know if this is orthogonal as it moves around. Even though you can have this thing pointing any way you want, but what happens here is during my alignment procedure, I need to know that my camera is facing with the mount, orthogonal with or parallel, for lack of a better description, with the polar scope. And if it's not, then I know I'm going to have a real bad time. And I usually check this by just simply rotating the camera or the mount round and round. And what I'm doing is I'm looking to see if any of the stars decide to make a weird elongated shape. If it's a good circle, and again, I use Sharp Cap, and you can actually put the circle to go up there. Watch one of the stars to make sure it makes a complete revolution and lands back where it was. Because if it doesn't, and it's kind of does this weird elongated shape, you know you got a problem.
Yeah.
That's more or less how Sharp Cap's built-in polar alignment kind of works. When you have it upright and then you have it at 90 degrees, and then it calculates how far you need to move it. And that's I get great results for that on my telescope mounts. for some reason, I still can't get it to quite go for my Star Adventurer. But I did recently, I got a new base for mine because the equatorial base that I had before was kind of wobbly in altitude.
Oh, yeah. So you probably got flexure
in it. So now I have a more firm one. It didn't perform much better the last time I took it out, but I'm hopeful that hopeful it'll work in the future.
I've had some immaculate alignments where I just found that everything stayed in place for 1:30. I've gotten as much as 2 minutes of exposure, but I was shooting anywhere, like 85 millimeter, 100 millimeter, and I've gotten up to 2 minutes with like very minimal to no star drag.
Adrian, the last December I could almost 5 minutes with a 55 millimeters lens, a Konica Minolta in my Nikon, with the Star Adventurer. The lens was very short, so the declination doesn't pull me, and the AR goes fine in the alignment.
See, I have an 85 1.8 that I tried out that night, and this is a big old 85 for the Sony that I didn't use. It won't show. I have an 85 1.8 Canon that's smaller than this, and I hooked it up to the 6D and said, I just seem to have pretty good polar alignment. So let's shoot the North American Nebula. Why not? And let's see what I can get. And so I took some frames at 1:30 each frame. Stars were staying round, but I then learned that the exposures were perhaps a little too long because they were bloated. So I still have some more experimentation to do, but yeah, it's fun playing with the Star Adventurer.
Yes.
Yeah.
I'm sending to you, or to all of you, a file that I did with the large Magellanic cloud.
I think the best thing here is learn drift alignment. I hate to say that, but there's nothing that beats drift alignment.
Yes.
To say that. Learn drift alignment.
Or shoot pictures like I have in my background where your polar alignment doesn't quite have to be as you've got a wide angle lens, and it doesn't have to quite be on. You at least get a minute, and your stars stay round because they're all small. As soon as you dig in and you want to do Rho Fiuchi up there, then your polar alignment has to be more spot on.
Well, this image back here, I was in a dark place, and I was using a Sony mirrorless camera that was really sensitive. This is a half hour's worth of 30-second exposures,
which is
that was on
really
my Star Adventurer. Fast lens, sensitive camera, and dark skies, you can compensate for bad tracking.
Yeah. What do you remember the Bortle rating you were at? Because this is in
the Atacama Desert. We were near San Pedro de Atacama, so it was really like Bortle 1.5 or so, but it was quite dark.
Yeah, this was Bortle 2.5, I would say, behind me. And so it was an unmodified camera, and you're seeing some of the lines heading to Rho Fiuchi, this region over there. You're seeing a little bit of that. That was unmodified. So I kind of I want to head back there and see if I can, get in there a little more when it gets dark in this area. Mm-hmm. And of course, I'm also heading to Okie-Tex, so that's gonna be fun. I hope to get out of there with some really nice images.
I wish I could go. It's during classes for me, but potentially next year. Although I can really only support either doing Texas Star Party or Okie-Tex, and I usually pick Texas Star Party.
Well, I saw some images from Texas Star Party, and I said I may go to that next year myself. Someone came back. They came back with Omega Centauri and a few other things you could see from south, and I said, until I can meet up with Cesar and Maxi, that may be my best bet. Then when international travel opens up, I got to come down and struggle. Simon, I'm going to give you a call because I'm going to struggle with polar alignment in the south. And I'm going to get on the phone and say, Simon, what am I doing? and
just bring Simon with you. You know,
and have you help me with some of these methods.
Well, in this scope, I don't have. I have a polar scope finder, but
because you don't need that.
I don't need
because Sigma Octantis is a fantasy. It's something like yes, you know, never say, oh yes, we have polar star. Which one? Sigma Octantis. If you say Sigma, is that maybe Sigma is not in any constellation. Is a bright star, and imagine that Octantis is a constellation that anybody knows. And the worst thing is that Sigma. Okay, you give me a constellation that you never see, and you tell me that the star is not Alpha, it's Sigma.
Sigma, no, it's
a nightmare. This is our tools in the south. Come on.
All I can say is drift alignment. Sorry.
That's why I'm giving you a call.
Only
Simon.
we are.
How do I drift the line in the south?
It works the same.
To do that.
The same way.
And the drifting polar alignment goes very fine with those. But I do PH2 guiding, and that's gorgeous.
Yes,
that's the glory.
Something to look forward to.
All right, well, I'm gonna actually take off for the evening so I can get my gear set up and go to bed early, I guess.
That picture that I sent you was the last December of the.
Yeah, let me share my screen here so that everybody else can see what we're looking at here.
Good night, Molly.
There you go, Maxie. You can talk a little bit about it, and then we will focus on Bob Denny next. So
now, particularly this picture, I remember in those days I was previously to do a trip to the solar eclipse in the south of my country. And I have some problems in my family with my mom. She was very with some issues with an operation and in an hospital in that time. And I had to clean my mind. I had to go out of town. I tell my girlfriend, honey, I need to go out. Sorry. And I travel. And I
Christopher.
Oh,
can you hear me?
Scott, I'm hearing myself.
Yes, I've got Christopher Go is trying to call in here. I'll call him privately. Okay.
Okay. So I go to out of the town, my mount, and start to take. I think it was 20 pictures of 5 minutes.
20 pictures of 5 minutes.
And then I bring home and did it and blow my mind.
Hey Scott, can you mute your microphone for a second? It might be that feeding back.
Yes.
Is that better?
No, I think.
What are you hearing?
You and somebody else.
It's stadium announcement. Now batting. For the New York Yankees. Number two, Eric.
Echo.
Jeter. Number 2.
Tengo.
Are we still hearing the echo? Yeah, we are.
Something changed.
Yes. We continue listening ourselves.
Well, Maxie, still a very beautiful picture. Very beautiful picture.
Thank you, Adrian.
Maxie, why don't you try muting your mic for a second? See if it goes away.
I tried.
Okay.
Testing.
Testing.
Okay, now somebody say something.
I think it's good now.
No,
I'm still hearing it.
I'm still hearing an echo. I think it's coming from Scott. Scott, you got to mute your mic. You got to mute your mic, man.
No, not mute it physically on the thing. There's the button that says mute in Zoom. Okay, so I should not hear myself now, which I don't.
Yep, it was your Zoom mute, Scott, I think, with someone coming in.
Yeah,
the stadium echo is gone and Jeter is out. So
yep,
I guess we'll continue.
Now we can go.
I love how everybody goes all silent. I love how everybody goes all silent. I still hear myself. Uh-oh, something's going on.
Scott, I think you're the problem.
No, Scott just muted himself, so we can continue.
Cesar, ¿cómo andás? How are you?
I guess since we can't hear Scott, I'll introduce Bob Denny. I still hear an echo.
All right, I'm muted. I don't think I'm the cause.
No, it's. Go ahead, Jerry. I think
Scott,
we can.
Sorry, real quick. I know you can hear me, Scott. Do you have TeamViewer? I can log in and reroute the audio so it fixes it while these guys do their thing, but we'll stay muted.
Scott will chat.
All
right, Jerry.
You can talk.
Can you hear me okay?
Yes, we can hear you.
Good.
Yeah, we're good.
All right, so Bob.
Now we're good.
I've known Bob for at least 10 years, I think. Met him at NEAF the first time, I think, and I learned about Bob when I got involved with the ASCOM system early on, about 10 years ago, and or 12 years ago, actually. And he's a great guy. I enjoy talking to him about a lot of different things. And we've had some good discussions at the NEAF, I think, Bob, over the years. And you've recently been evangelizing the Alpaca cross-platform system for ASCOM. Is that right?
Yep. That's been my thing for 2 years, but I don't take credit for the technology. I'm just a flag waver.
No, but you're also an excellent resource and go-to guy on how this stuff works.
I do know that.
So don't sell yourself short in that realm, because everybody needs to, when they get into it. I wrote driver for the PMC8 system, and it's a lot of work to get it correct. And there's not a lot of good examples in terms of, they show you what you need to do, but not how you need to do it to get it to work with your mount. That's one of the things I found early on when I was developing the mount ASCOM driver. It's gotten better. There's a lot of other examples out there now to go by. But I started my development about 5 years ago, I think it was, on the PMC8 system.
Well, there were templates. There have been templates for almost 10 years in C#. But that just shows you what you need to do, but not how. And the only way you know how is how you know how your equipment works. And that's the whole point of a driver, is it isolates the applications out there like SGP and My Software and Maxim and whatever else from the gory details of how your system, whatever it is, a focuser, a telescope controller, works. So it is true. I'm going to share a screen just for a brief moment.
It forces you. It actually forces you to understand your system a lot better when you're trying to tell the ASCOM driver how you want something to be done.
Yes, it does. And there's I almost said something bad. There's a boatload of information out here that for developers and for application developers about the general principles. What do you need to know what to do, how you manage errors and retries. You know, if somebody beats the heck out of your system by asking your mount for the RA 500 times a second, you need to isolate the innards of it from that and all sorts of stuff. So there's resources there, but you have to know that's there and use it. So thank you, Jerry. I appreciate the intro. I'm not going to take too much time tonight. One thing I want to announce is that one of the projects of the ASCOM and Alpaca group has been to build a set of reference simulators that are cross-platform, that'll run on Linux, Mac, and Windows. And they speak Alpaca, and every single one of the devices that's defined in ASCOM, all of them are simulated as a reference implementation. Those simulators will behave according to the spec. And Daniel from Optech has implemented those, and they're going to be out there shortly. There's a few of us who are testing them right now. They look really good. They all pass the conform, and they will run on any platform, which is totally cool.
Yeah, that's cool.
Yep. And because they speak Alpaca, any app on Windows can use them because of the middleware that translates the old ASCOM into Alpaca, and that's already out there. That's done. It's been out there for almost 2 years. So any application can check themselves against those simulators, and eventually what they call the Omni simulator, that will become the standard instead of the ones that are there now. So we're making a lot of progress in that department, and it's good news. The other thing I wanted to talk about is one of my own projects, which Scott said it's okay to talk about, and that is a new version of Pinpoint. And there's a 64-bit engine, but I should probably explain what Pinpoint does first, and that is it's a library or an engine that you can include in an application, or you can script it from any one of 20 languages on Windows. It is a Windows resident engine, but it does astrometry similar to all the other. You've seen a lot of astrometric plate solvers pop up in the last 5 years. The difference is Pinpoint, when it solves, gives you a very accurate centroid and RA index of every single image in the whole field, no matter what the
profile.
Well, not only the profile, but any sort of optical distortion that's present. Various telescopes have, sin X over X, or all different kinds of distortion in their image. So if you just try to scale across the image from RA index to X and Y or vice versa, you'll get errors because it's not just a flat transform. So it measures that optical distortion all automatically, and you just call it, and it does all this stuff, comes back to you. Dr. Donald Bruns used the centroiding in Pinpoint to measure the stars for his recreation of the Eddington experiment in 2018 with the solar eclipse. And it was Pinpoint and Astrometrica both giving effectively perfect centroids of the stars and under tough conditions.
Mm-hmm.
And he used that to get a very, very excellent measurement of the warping of the stars due to gravity. It's quite an interesting thing. I'm not going to bore you with more of it, but that was part of what Pinpoint does. So it does a lot of different things, and I'm not going to.
Do you provide data or a graph that shows the field curvature as part of that?
No, it has built in a set of coefficients for a two-dimensional polynomial. My automatic distortion correction, predates the SIP that came out in 2006. I didn't know anything about it. They hadn't done that yet, but I did it in 2002 because I was dealing with a Centurion telescope that was a corrected Newtonian, and it had extreme sin X over X distortion. And I had a customer with 6 of them who was running this thing all over the sky, discovering asteroids. He eventually became the first amateur to be designated by the MPC as a survey. But in order for him to turn in accurate enough measurements, astrometric measurements, it had to figure this all out and take it out of the equation and submit accurate positions all the way across the field. So that was a guy named Kwang Yu Jung, and he named an asteroid after me anyway,
Cool.
which is cool, down in the 20,000s. 23257 or something like that. I don't even know. Anyway, asteroid Denny.
We got two asteroids with us tonight. We got Scott Roberts and Bob Denny.
Anyway, the point being, it does a lot of work to get science quality astrometry hands off. You just call it and it comes back, and you can pick your way through all the objects in a collection and get really accurate RAN deck of everything. And no, it doesn't have beautiful pictures of it's not like CCD. What's that thing that measures the beautiful, creates beautiful pictures?
CCD inspector.
Yeah, nah, it doesn't do that. It just does what you need to do to get the astrometry, and that's it.
Okay.
No UI, none of that.
And
you can embed it in any application and call it with simple calls. And it's really pretty simple. So,
okay, cool.
So what I did with Pinpoint 7 is I made a 64-bit, and that was requested by a government employee in Canada who is using it with MATLAB 64-bit. And since MATLAB can call COM objects, he was using that to measure the positions of objects in the sky. I think it was space surveillance, as they call it. And so he wanted that. And then SGP, the guys at Main Sequence were coming out with a 64-bit version of SGP. So I needed to make a 64-bit version of the engine, which I did. And it was interesting because there are two really, really big libraries that are included in that. One is CFITS.io, which is a recognized industry, science standard FITS.io library. And I needed to convert that to 64-bit. And then LAPAC, which was converted years ago to CLAPAC, is a linear algebra package, and it's huge. And there's the regression test scheme runs for a day and a half in order to make sure that it's right. But I use CLAPAC to do the distortion correction using singular value decomposition, which is a matrix algebra scheme for taking measurements and then fitting it across the field and creating the coefficients for a two-dimensional polynomial. I know I'm probably getting too technical for the audience, but you asked the question.
I'm probably the only one that likes this stuff.
Anyway,
I use a MathNet library to do the alignment routines.
The point being, it does it, and I don't try to talk to people and tell them how it works internally because it's not that interesting, but I'm glad you're interested in it. But the point is, it does that. So that's one thing, the 64-bit engine. The other is one of my customers for, let me get this right now. I have to pop this up here. Now, share screen. Where is I thought I would be able to share only the browser, but unfortunately it looks like I'm sharing the whole damn screen. Can you see this? Well, you know what? I'll just expand this thing to the whole thing. I don't know why it wasn't able to pick this browser out of the other stuff, but this is the Atlas All Sky reference catalog. And you've heard people say, oh, you need to use the Gaia catalog, DR2, right? Well, this is Gaia on steroids. It not only has the Gaia information on it, but it also has, I don't know if you can read this, but it has APAS, all sorts of other information in here. APAS, by the way, is the AAVSO All Sky Photometry Survey catalog. They measured millions of stars for photometry, way beyond, and you know about that also. And that was done with our scheduler over a period of several years, like 6 years, both in the southern and northern hemisphere. Arnie Hendon led that project, and then Dave Smith made the system that gathered the data for that. But APAS was done, and it could not have been done, according to Arnie, and you can ask him, without our scheduler. It ran all night, every night that it could, and acquired millions of images on 2 telescopes to do that. So Atlas is a really cool reference catalog for plate solving. You'll see this is going to be in use with other people too. It's big. Each magnitude band from 0 to 16, 16, 17, 17 to 18, 18, 19, 19 to 21. Each one of those bands has 64,800 files, one per square degree of the sky. And so it takes a bunch of time to get those files down and get them decompressed and so forth. But once you have it,
what's the magnitude limit on it, on that Atlas? Is it
22?
Like 22, really? That's amazing.
It goes almost, well, I think 21 and a half, 22. It goes way down, and it is a super high quality catalog. And I have to thank one of our customers, Eric Dosset, who pointed me to this catalog, and I started looking at it and I go, 64,800 files? No way. But you know what? Windows just doesn't even break a sweat. You just take some time to put them in there, but once they're in there, it works great. And so now it's capable of using that as the reference star catalog. And so you can start working really deep. And I have customers now who are working down in the MAG 19, 18, 19 area. And so this is just perfect. And
that's nice when you're doing with a smaller field of view with these longer focal length telescopes also.
Well, but you have to take long exposures to get enough stars down that deep.
Right.
Narrow field work with science is tough, no matter what. And the more money you spend, the more data you get per unit time. So the bigger the aperture, you know what I mean. But anyway, you're right. It has its advantages. I'll stop sharing that. Oh, you know what? There was something else I wanted to show you. I'm sorry. On this thing, there was one other tab, and that's the archive, the ADS reference for this. And if you're interested, if you look at the help for Pinpoint, you'll get all the pointers to all this stuff too.
Good.
And by the way, here's the pointer to Jerry's thing, which I just thought was fascinating. And I put that in the chat, the public chat also. So I'm really interested in this.
Good. Thank you.
I want to get the V7 Pinpoint, which is almost, it's in field test now, but I want to put a bunch of these images through that to solve and see how it works. I'm really interested in doing that.
Sure.
Did I do this right? Oh, there we go.
That's it.
Yeah, now we're seeing
All right. And so I may not have shared it before, but here's the ADS on the Atlas catalog. And there's the original thing that I posted. So I'm sorry, I didn't go the whole 9 yards on that. So that's what I've been up to. And on Alpaca, it's charging ahead. Simon, he's not here right now, or his picture isn't here right now, but Simon helped tremendously last year by putting me on a live stream and allowing me to give a detailed briefing on this, which is on the ASCOM site, which I will now share. So if you go to the ascom.standards.org website, which is very simply that, right at the top, there's this video, and you can see that, and I've got it expanded because I don't know how to share a window with Zoom instead of an entire screen. So that's this here. I don't know why it started in the middle, but anyway, you probably can't even hear this. Can you hear that? Probably not. Anyway, okay.
We're not hearing it.
Yeah, okay. That's enough. Anyway, it's there. and
or send the URL or the link.
yeah, I'll put that on the chat in just a sec. That's right at the very front of the ASCOM website, which it's probably worth seeing that. I'm going to put this on the chat right here. 1, 2, 3, click. Boom. ASCOM-standards.org. That's the public chat. It should have come through by now.
Yeah,
I can't
cool.
seem to
That's
shrink
good.
my.
That's good.
There we go. Okay. Anyway, thanks to Scott.
I guess
that's
he's
my
still working
thing.
with
That's
Simon.
yeah. He really helped last summer with that, and so thanks to him. My thing is just to make the ecosystem. You know how we have the Google ecosystem and the Apple ecosystem and blah blah blah. Well, the astronomy ecosystem there are two of them. There's the Linux Indie and the ASCOM, formerly Windows ASCOM, and now everything ASCOM ecosystem. Alpaca is a version of ASCOM, we'll put it that way. Anyway, we're trying to make it universal so that if you have a piece of equipment and you write a driver with Alpaca, anything can talk to it. And that's the whole point. And a piece of equipment can have its own Wi-Fi and its own little microprocessor and speak Alpaca, and everything on Windows, Linux, or Mac can talk to it. And that's our goal. No libraries, no C libraries, C++, none of that stuff. It's all over the internet, network connections. So that's our deal. Anyway, thank you for the opportunity to speak. I know it's been highly technical. Jerry, let's get together. And Scott, thank you very much. As you said at the beginning, I'm a technologist, not an astronomer. So this makes my segment a bit different. And I hope I didn't put too many people to sleep.
No, Bob, I think what you've done is especially with, if nothing else, anyone gets out of it, is your technology is what makes the things we like to do possible. And things like plate solving for what we're looking at in the sky. If we want to image something, or if we want to polar align, that's where your technology makes it easier. How do I do it? I look for the North Pole and hope I'm right. How do I do it if I use your technology? Press a button and it finds it. So that's where the connection is. And maybe I don't understand all the nuts and bolts, but I understand that is very important.
Well, it gets people up to speed very quickly. And we've had customers that have had their stuff. They started out brand new and started into astrophotography immediately. And after 3 or 4 months, they've got great images. It's pretty amazing when they dig into the technology and learn what's possible after just a few short months. It took me 2 or 3 years. Yeah,
Scott opened the door years ago. I had written the original plate solving engine back in 2000. And in 2001, I was in the Meade tent at RTMC with a Meade LX 208 inch, bouncing around, taking pictures, 5 or 6 pictures, coming back, taking another 5 or 6 pictures of the same field 15 minutes later, and then 15 minutes later, bringing them in and blinking them and seeing the asteroids moving and being able to measure those asteroids and send the report to the MPC. So that was my original reason for getting into this. And Scott opened the door for me. And once again, Scott, thank you very much.
I got to say this in regards to Alpaca, for the people who are watching at home, it's not specifically your job, but the more you guys can put in the effort to tell these companies that you want to use. Oh, hold on, what's that noise? Is that me muted? Can you hear me?
No, it wasn't you. I don't know what it was. Again. It sounded like crickets.
Oh, that was weird. But you can hear me now, right?
Yes.
Yes,
okay,
yes, Jerry.
All right, so sorry, I've got to start that again then, just in case, because we're having audio issues. With ASCOM Alpaca, for the guys at home who are watching this, we kind of need you guys to actually go out and speak to the manufacturers and say, hey, we want Alpaca drivers. We are doing our part to the best of what we can to try and get as many of these people on board. But the more of you that are asking for it, the better this gets, and the more likely Alpaca is going to be around. As far as we're concerned, it's not something that's just going to show up and go away. It's going to be around, it's going to stick around, and whether you like it or not, we're all going to be using it. There are more benefits with Alpaca than there are negatives, to be totally honest. And quite honestly, especially for education, the way that it controls telescopes and allows so many people to see what's happening, as opposed to everybody huddle around the screen.
Simon, doesn't it make sense also to talk to the client application developers to say, I want the Alpaca in this app? That's where it starts for the user, right?
Yeah, I mean, as long as they can just keep harping at anybody and everybody to start using Alpaca, and I'm not saying this just to get you guys to, convince you guys to use it. I've seen it in action when we did this demo. Obviously, with doing the video with Bob and the guys over at Optech, there was more to it than I saw. And we had this private one-on-one with Daniel, who, has been doing a lot of the programming. And he showed me all these little things that you guys never got to see because they're not completed yet. They're probably now, but
they are. They're
they're done now.
The Omni Simulator is one of Daniel's things, and it's out now for testing amongst the group. And so he's just a genius. And
he is.
Jeff at Optech, I thank him. I call him every few months and say, Jeff, thank you very much for funding not only what Daniel does for you, but for what he does for the community.
But I mean, so this is one of the things I'm trying to explain to people about the Alpaca, though, is the example we use with the focuser. You can have, especially with the pandemic, we can all be on Zoom, but we can all have this web browser open up to a certain extent and control this focuser through a VPN private network or something like that, because obviously this doesn't work. It's not an internet protocol. It doesn't work over the internet. But if we create a VPN, we can all log into it, and one person can control the telescope, and everybody else sees the telescope moving in real time, as well as the statistics. So you don't get two people who try to control the telescope. You can have one person who does one setting, and then the next person can come along in the same application, make a change, and it happens for everybody. And I think that's where the unique side of all of this comes from, and how you guys at home want to utilize this and tie this into your system and your setup is entirely down to you. But from an educational standpoint, to me, it's going to be a game changer as far as I'm concerned.
Well, and the key is individual equipment makers want to create their own little world and have everybody tie into them. And then the next guy comes along, well, you need to speak Polish to me, and you need to speak Chinese to me, and you need to speak Espanol to me. Well, no. The whole point is your value is not that you are preventing your competitors from being in the field. Your value is being better than your competitors and being in the same field and operating on the same level playing field with regards to talking to the instruments is where it's at. That's what makes it go. And that's what standard protocols do between the programs and the devices. And that's what Alpaca's for, and that's what ASCOM has been for. And that's why I'm here. That's my big, and I carry that flag all the time.
And it's cross-platform, more importantly.
Now, yep, that's the big change in the last 2 years, is that it's moved out of, instead of having it hooked in with the Windows scheme where different programs can talk to each other in any of 20 languages on Windows. A program and a driver can talk to each other, and the program can be in one language, the driver can be in another, and they can be one of 20 languages. So you have a lot of flexibility there. But outside of Windows, like Darren from Australia said, 3 years ago, why can't I install it on my Mac? Well, now instead of it being using the COM system or the local procedure call on Windows, it's been moved over to network connections which can occur on the same machine or across machines. And the implementation is still language independent because every language on every platform knows how to speak REST. And that's what it's based on. So it basically really moves it out away from being specific. So people like SGP, CCD Autopilot, and Patrick Chevali wrote Carte du Ciel on and it's a cross-platform thing. And he jumped on this bandwagon right away. And any version of CDC can talk to any Alpaca based device. And because there's middleware on Windows, which is there, somebody who has a plane wave, L500 mount, which has PWI4 as their control system on Windows. It doesn't run on any other platform. A plane wave machine on a Windows box. It's a fabulous control system. It's a fabulous mount. It has a ASCOM input, but with the little thing that Peter Simpson wrote, now anyone on any Alpaca device anywhere, Raspberry Pi, Linux, Mac, it doesn't matter, can also talk to that plane wave and run it. And that's today. That's not a dream. It's right there right now. So that's where it's at. And I know I've probably gotten on. I need to get off my soapbox. But anyway, thanks for the time.
Sure.
And Simon, thank you for helping last year. That was
no
great.
Problem. No problem.
No, that's very interesting. In the chat, we were talking about building it in DSLR cameras. Canon already has a camera that they designate for astronomy. So something like having ASCOM, the Alpaca software built in with the mirrorless camera. I mean, I could, if I can just slap my camera up there and let it polar align, tell me where I need to move it in order to be perfectly polar aligned, that would be wonderful.
Cameras are a real tough issue. It is probably, if you think about all the other devices we use for astronomy, those things are fairly straightforward. Focusers, domes, filter wheels, mounts even. But cameras are tough. And there's a big technology shift going on from CCD to CMOS. The characteristics of the sensors are different. There's a lot of low-level raw functionality that's being pushed out to the applications that probably should be contained within the camera. And Scott, shut me up if you think I'm going on too damn long. But for example, and this is only an example, a CMOS camera is better off taking short images because of the way the sensor works. So if you want what amounts to a 20-minute collection of photons on an object, you may have to take 20 one-minute objects or 50 or 60 30-second exposures. Well, how the hell do you take an 8K by 8K sensor and put 50 of those across the wire into the computer and then stack them? That's outrageous. So, there's a problem with that. SharpCap is more of a video type of thing. It takes in, high speed, short images and then stacks on the computer and you get to watch the thing form and be wonderful. But there are applications where you just want to you want to tell the camera, give me 20-minute exposure and give it back to me. And in order to do that, what we did in the standards was to add a sub-exposure interval that you can tell it, okay, I want 30-second exposures, but I want 20 minutes worth of these. And it's up to the camera to combine them inside the camera and return a single image. With NVIDIA processors, which are dirt cheap, these camera makers are eventually going to start making their cameras really smart, but it's not there yet. It's all in transition right now with the technology, and I expect to see these cameras be way smarter in not that long. And we don't want to change things in such a way that we hamstring people by making forcing them to go the old way instead of allowing them to go the new way, if you know what I mean. So
yeah,
anyway,
and that
now
you know
I've
that
really
also
overdone it.
Yeah, it also comes down to motive of the camera makers as well. I think they're, and anyone can correct me if I'm wrong, but I think camera makers are seeing that the DSLRs are being used at night, whereas I think initially you developed the DSLR, you didn't take this camera and make it so that it could shoot stars. The intent was to shoot landscapes in the daytime, and the sun was the basis of light, and that's how the thing was developed. But now, you know, astrophotography, we're proving that you can take this camera and shoot this back here on my screen and shoot your aurora, and it can do a good job capturing photons at night, but then you've got the thermal noise and the other things that are going on. So there's dedicated astro cameras to deal with that, and you know, and so on and so on. So yeah, it's one thing to have the technology to do it. It's another thing to make your camera makers understand that that technology will sell. And that's, you know, the business part of it is very pretty important.
You have a really good point. Now, I'm sorry, Jerry, but I want to answer him. The very last thing that was discussed in 2009 amongst a set of camera makers at the AIC conference in San Jose before the ASCOM camera standard, which is again a universal standard, was agreed upon and released, was the representation of the Bayer matrix that's used by one-shot color cameras. And having a universal way of representing that Bayer matrix, because the different camera manufacturers had different ways. And they all agreed that from the program, the application standpoint, we see Bayer matrices this way. And if your camera makes one differently, you have to switch it around. That was the very last thing that was discussed and agreed upon and compromised on before the ASCOM camera standard was released in early 2010. So for DSLRs, it's been out there. My big, probably boring lecture a minute ago had to do with the new CMOS cameras, which are monochrome with filters. And that's a whole different, ball of wax.
Ball game there.
Yeah. Yep. But you're right, Adrian, that is the camera makers. They all have huge markets. I mean, I deal with this every day. There's one camera maker that is their astronomy segment is this big, and their microscopy segment is the other 90% of their pie chart. And so trying to get their attention for the customer to fix something is almost impossible. And so you have to look around who's focused on astronomy, who's delivering good equipment, but more importantly, who's responding to the astronomical customers' needs on a timely basis and fixing bugs and making things work right. And I'm not going to say who's who, but that's the key. And that goes back to what Simon, I can see him laughing and, yeah, you're absolutely right. Boy, is that ever right. Putting pressure on the vendors to deliver what you paid them for is my number one. Whoa, I talk to people all the time. Well, my mount went this way and it didn't do that and it didn't report an error. Well, you know what? You paid them money. Why don't you get on their case and tell them to make it do what they sold you it would do? Well, they never answer the phone or, whatever. So anyway, that Simon's right. Make them behave.
Right.
I'm sorry. I know I probably went way over. Scott's going to call me tomorrow and go, you know what? You need to tone it down, Bob. I know he's going to do that.
You guys hear me okay?
But you know what?
Yeah, we can hear
you. Guys hear echo
we can
right
hear
now?
You now?
What the heck?
We can hear
and
you.
no echo.
No echo. Okay, great. Okay.
I'm done.
I was going to say one thing.
Good man, Bob. Let him have it. Okay.
Sorry,
So,
Jerry, I cut you off 5 minutes ago, so I'm sorry.
That's all right. I was just going to say one thing with the camera manufacturers. We're kind of in a golden age of cameras, and I think it's going to change to the bad here before too long, where they're building cameras that are useful for the mass consumers that are also happen to be useful for astronomy. But that's not going to last. I don't think that's going to last. I think they're going to move on to some other technology that's not going to be good for astronomy at all. And that's my fear.
Well, that spells opportunity for a small company who wants to get into this market and focus on it. And as long as we still have free enterprise, that's good.
You know, the interesting thing here is there are companies, and I will not name them because I'd rather you guys discover them in your own time, but they have cameras dedicated, or in fact, sorry, their company is dedicated to nothing but astrophotography. And I'm going to tell you now, it is not the big two that you think it is. So be prepared when this not new, okay? The cameras themselves and the technology has been around for a very long time. The company, on the other hand, is starting to show up on people's radar. They are focused on nothing but astronomy. They know it's a small market, but they don't care because they're all astronomers.
It's good to know, and I know good homework for
I know at least
like
one
myself.
of those that Simon's talking about. So, and he's right. And I will add only one other thing. Watch for what happens inside the camera with regards to processing the photons that come in a way that, one, science people can account for every photon without any kind of fiddling around or transforms. They have to be able to go from photons in to signal. That's important. And for art astronomers, they have to be able to get data that they can use to make beautiful art. Those are the two requirements. And processing inside the camera is where it's going to happen. And just think what an NVIDIA video processor inside a camera, and they're dirt cheap. Think of what that can do instead of the old days back when SBIG had a CCD chip that was being clocked off the chip and read into the computer over a USB line with no buffer. That was the worst of all worlds right there. You had to stop the CPU. It was horrible. Otherwise, you'd get horizontal banding. Remember that? Oh, set your priority to high or you'll get horizontal banding. What the hell? And that's still there. There's people with those cameras still there. So it lasts forever. All we can do is pray that these people don't set another 10 years worth of pain into their cameras. That's my thing.
Like I said, there is a company that is their primary focus is these problems. Again, I'm not going to say who it is. I want you guys to discover it in your own time because they're not fully realized yet.
Well, that's good homework for me. If I get into a pinch, I'll beg for some help. But no, that's something that I think I'd love to look up. In the meantime, I'm firing away. The interesting story about the 60, and then we can move on, is the fact that it was made to shoot portraits or whatever, but Canon found that a lot of astrophotographers would go to it. Just the way it was built, it handled those photons at the night sky a lot better. There was less noise coming in, and the images you ended up with were a little cleaner before you started the post process. Something about this camera, not the Mark II, but the original that's now about 10 or something years old. And there are a lot of astrophotographers, well, now including myself, that are using this camera. I have a newer mirrorless, and I still don't seem to get the quality of image that this produces. And not with this lens, a different lens, but it's the quality, it's the image itself. Just it comes out cleaner. It's, it's what's behind me, and it's it's just something interesting about the camera itself and the technology that's in it that it just happens to work, and it's kind of an agreed upon camera until we go to a real astro camera like you're talking about, Simon and Bob. The dedicated astro camera takes care of the flaws, the thermal heating and everything that our DSLRs go through when we're trying to use it to do repeated imaging. For nightscapes, it works just fine. For classic astro, you get that thermal heat, and your sensor it heats up, so you've got I guess you've got like the dark pixels or whatever you have to deal with, and the cooled CMOS sensors take care of that problem. So
I get that. I have a
yeah,
friend.
a number. Very interesting discussion, and I'll go ahead and mute so we can move on to the program myself. But
Well,
it is
Adrian,
definitely an interesting. Go ahead.
I want to
Bob.
say one thing. I have a friend who's a former Army aviator who went from enlisted to officer and took a physics degree as his college. And now he retired years later. He's got quite a military career, but now he has a backyard astronomy and he uses DSLR. And I was at his house on Friday night and his astro images are just stunning. So impressive. So I get it. I mean, there's people like yourself and other people who are just knocking them dead with that. And I'm sorry if I made it sound like you're at the low end of the spectrum. You're not. What he has done, and I'm sure what you're doing, is just amazing. So I'm sorry if I made it sound.
That's okay. And I've done it. I haven't done it for many years, but there's a passion for it, and it's just with each image, it gets easier and better. And a lot of what I've done lately is just go to where it's dark. In Michigan, we do have places that are darker, and less signal to noise coming from the sky really helps. I mean, and that's just one thing that I've noticed. So it's a pursuit, it's a passion. It isn't necessarily to be better than Cesar, who I know is coming up next, but it is. But Bob, it is just Bob, real quick. My own love of the night sky that drives me. So,
are you going to stick around for the after party, Bob?
Yeah, I wasn't going to. I have to get up really early tomorrow morning to go travel, but yeah, I'll stick around.
If you stick around for the after party, let's carry on this conversation. So let's move on with the.
That's fine with me.
Move on.
Yeah, I'll be around. I'm going to duck out for a minute now, but then I'll be back.
Okay. All right. So we had a great discussion. It was all good and healthy here, but we do have up next here is Cesar Barolo. Cesar is at Optica Sirocco in Buenos Aires, Argentina. Cesar, are you still on with us? There we are. Great. Cesar, he's been on many of our programs. He has been one of our hosts, special guest hosts on the Global Star Party. And we always enjoy Cesar's adventures in, rooftop imaging from his balcony, and the great work he's doing in, renovating, a historic observatory complex in Argentina. So, Cesar, I'll turn it over to you.
Hi, Scott. Hi, everyone. Yes, we are awaiting the lunar eclipse tonight, or in the morning, early in the morning, and I found some old pictures from the last lunar eclipse in 2019, sorry, the same year that we have the total solar eclipse in San Juan, in Argentina especially. And I share some videos and pictures of my latest pictures of lunar eclipse. I don't know if you can see now here. Let me. Okay. Well, this is the 2004 lunar eclipse in Argentina. I made the experiment to make the different sequence of the eclipse, a half part really. Was my first experience in solar eclipses, This one was the latest eclipse. We were in the River Plate coast that is near to my home in the Buenos Aires Rio de la Plata River, that is 60 kilometers wide. It's like a sea, but it's of course only fresh water, no salt water. It's not the sea, it's only a river. It's a really, maybe one of the widest river in the world. We have an opposite to next eclipse in a few hours. This one was in the rising of the horizon, and we made a small safari where the people go to fish in the coast of the river. This was some pictures. That night I don't have my camera prepared and use it only in the worst way, my cell phone. And well, was more of that we had fun with people that came to make a small safari. Here we are all friends that say, okay, I can go to the coast, to the how do you say in English when you have this area? Well, I don't know. It's the coast. It's an area where the people go to walk, ride biking, and
the bus walk.
Yeah, thank you. And we went to this place with people that normally we meet in different safaris and of course eclipse or different things. And well, here is a small video. This is, yes. This is something social because it's, this is the place. Here we had an airport near to the place because it's at only maybe 3 kilometers from my home in Palermo, in Buenos Aires. Of course that we had a very fun. This is my son Agustin. You can see the small one that is 90 millimeters refractor was great. I took all pictures that I took it with this telescope. And was a great telescope that we had from the eclipse in San Juan. We carry a lot of this for the people to use and take pictures with their cell phones. And I had a very great experience of filming and take pictures with this telescope. This, there are videos. I don't know if the people, yeah, well, very noisy, sorry. And we had fun taking pictures. This is another eclipse from 2015. And here I used another telescope, a Maxutov. I don't remember exactly what that was, that from the rooftop in my home. And well, this is from the eclipse of 2015. And well, I'm preparing with this for tonight, and I using not a telescope for tonight, if not only camera, but it's okay because I need more with 300 millimeters and using in APS-C sensor. I have near to 400 millimeters, and it's great to have a not so for this kind of eclipse in Argentina this time for this lunar eclipse. Really is something that we could shoot the first time of the eclipse. Maybe we don't know how many will can see the difference with the shadows and the colors, because actually normally in this maybe in 10 degrees over the horizon, when the shadow is starting to be more visible, the moon is turning red, and you have maybe the situations where the things are mixed with the colors, and maybe we don't see really a gray effect of the eclipse. We don't know. It's something that maybe it will be great, awesome, or totally say, okay, it's the same. We can see nothing because it's only the first part of the eclipse. Well, but I can go to sleep now, and I return to share the live image at our local time of 6 p.m. or where is central time is 4 a.m. I think from the eclipse is here.
Cesar, the UTC is almost 9 hours.
Yeah.
9 a.m.
At 9 hours,
here,
yes.
6 a.m. is here.
6 a.m. Yes,
we have 5 hours to go to sleep.
Yeah.
Caesar, real quick. When you do these outreach programs and show people what's happening, and something like the eclipse, because I'll never forget the reaction from my neighbor who had come out of his house, and he was just doing whatever he was doing, and he sees me with my telescope, and because I've got my lasers and cameras, and the first thing he's like, what are you looking at? And I was just like, I'm looking at the moon. And he's like, so what? What's the big deal? And I was just like, why don't you actually look up and look at it?
Oh yes.
And it's what is the reaction from people that you get, because the moon is such a mundane thing to everybody, but when they see it, what is that reaction like to you?
It is so fun. It's so fun because when you go to the public place, of course that the people that are in the video that I show, shots I show, is people that is from, they are all amateur astronomers. Maybe they was only 7 or 8 people, but they are amateur astronomers. But the fishermen that all times are in the sidewalk of the place of the river, they was really with a mix, first of all, that they know something wrong with the moon, and they came to us to ask, what is what is wrong with the moon now, because it's half moon, half red, and it's every time it's fine, because you have it's fun because you have the opportunity to explain, and the people say whoa, and watching your telescope.
I think maybe it was something like,
I love this.
¿Qué está pasando?
Yes, this is the most slang.
Hey dude, what's happening?
Yes, hey dude. Yeah, yes. All people, all time. In Argentina, the people, you don't need to invite to the people that came to came to see to the telescope. All people is curious and social, and it's another immigrant country, and we are a mix, and all people don't have any problem to say, is it possible to make something and you make something different or curious? You know, maybe I am the same when the people fish something big and who is your, how kind of fish you fish? You know, it's the same. When I use a telescope in public places, it's you need to be prepared to explain to the people some type of things. But I think that the people is smarter than the media. This is incredible. But sometimes in the media, you can listen the most stupid things about eclipse, moon, and say, okay, this guy is really talking about this in TV. I can't believe it. When the people, normal people that don't understand astronomy, many times, most of the time, they explain you, they ask you about the questions in the right, they make the right questions. This is incredible because maybe it's a fisherman, they say, okay, what's wrong with the moon? Why? I will say, okay, you can see, for example, in a moon eclipse, this was interesting because we have the river is like a sea because we can see the another coast of the river, and it's how do you say, the idea of see the moon in eclipse, where do you have the shadow of the earth here, and do you have your horizon that you're watching, is great because for have an idea of, okay, you see a flat horizon, but when you see the project, you see the entire shadow curve, and they say, oh, okay, well, it's not flat. No, but I never found the people talking to me. I was looking maybe for, especially in eclipse, that say, okay, this is impossible because the earth is flat. No, fortunately, never. I couldn't. I don't have the idea of the opportunity to explain that. But yes, the people have more idea. It's more curious, and it's really nice. Share image in your telescope, or explain something, or simply ask about this type of events. It's great, really. And I'm prepared to go in 4 hours more. Yeah, 5 hours more, go to the rooftop. But really, I need to go to sleep a little and return tomorrow early morning. Yes, because sure, it's okay for me. It's okay for me, but it's because tomorrow I'll be having a hard work day, because we have Monday and today holiday day is the Patriotic Day, 25 de Mayo. Yesterday was holiday, and well, okay, I have a very, very belated work for tomorrow. It will be a nightmare. Okay, it's normal. Tomorrow is like a Monday.
By the way, feliz 25 de Mayo, César.
Muy bien, lo mismo.
I just thank you, Cesar. That's awesome.
It's a pleasure, and we return in 5 hours with my image, my mom eclipse image from the rooftop.
I wanted to let you guys know that I just stepped away to take a call from Christopher Go in the Philippines, and so he's got his rig set up and everything, and he's actually going to come on after he has lunch. He's getting lunch right now, so we'll continue on with our program, and we'll see some live images coming from the Philippines somewhere towards the end of this program. And then if skies hold up, I think Chris is going to try to get the eclipse live from the Philippines as well. So that's all cool. Okay, so up next is Maxie. Maxie, thanks again for coming on to Global Star Party, and we love your images, we love your creativity and your technique, and so thanks. We'll turn the show over to you.
Well, thank you, Scott, again for inviting me. Thank you, Cesar, Adrian, Simon. I saw your pictures in Instagram. It was amazing with the sun. It blows my mind. I started to follow you. So, okay. Well, I only want to show you what I did in 2019. In that year, we had two lunar eclipses. One was presented by Cesar in July. I remember it was 14th. But at the beginning of that year, in the 21 of January, we have another one. So I'm going to show you my screen in July, I couldn't take any pictures because when the eclipse started, I was working. So I only crossed the street, see the sky, and saw that orange. I wanted to be in my home with my telescope, my camera, and everything, but I was working. Tomorrow, I will try to take pictures of a partial eclipse in the rooftop of my house. So then I'm going to work. So I will sleep very shortly.
Oh my God. Okay. Well, that's like a real astronomer. So
yes. Yeah. And also we are in maybe 5 or 6 degrees Celsius. So it's very cold.
Oh.
Yes. Well, let me share my screen. Okay. Everyone is seeing?
Yes.
Okay. Well, this was December, but
beautiful image.
This is a little bit what I did in that time, in the 21 of January in 2019. Here's our 3 scopes. This a very Newtonian short, and this was my first telescope with my brother. But here's the Maxutov and 32 eyepiece and my cell phone. See, and here's the moon. Some stars. Yeah, I think was very 8 seconds of picture. So here's my brother Christian. He's watching right now. He's my sister-in-law Veronica, my nephew. No, no. You see me?
Yeah, we see you. Sorry.
Okay. Just hit continue.
And here's my dad, my brother Christian, my another brother Sebastian, and me watching the sky the same night. And here's where the start beginning. Here's doing in ocular projection, okay, by the cell phone above the eyepiece. So this is where it started. You can see the shadow. I think maybe this night it could be like this, very above the horizon, but this is taking pictures on, this is what you see through a telescope, okay? You see the shadow, you see the moon, and that's it. But when you start to take pictures with some, maybe 2 seconds of exposure, you start to see the color that you're seeing without the telescope. And here's a star that shining. So this is basically, I think, was 4 seconds of exposures. There's some tiny stars behind the moon, and that's blew my mind at that time. And you can see it's still working, and this is a finally picture that I edited.
This one was all with cell phone.
Always was with the cell phone, yes, by ocular projection. So I don't think tonight is gonna be this way, because in totally was besides the horizon. So maybe it's going to be like this, or maybe less, but in a short exposure, maybe the bright of the moon will kill the picture, but the another one maybe has some color. But we have some cloud skies coming from the southwest. See, here's Buenos Aires. Let me zoom it. Right here, Cesar. And I'm here, I'm right here in this 60 parallel. So you can see the clouds are disappearing and appearing, and they are very thin clouds, but it is the weather in here, because it's very wet in the Pampa. It's very wet. So okay, I'm starting to stop the screen to share, and that's it. I only want to show you how what I did with my cell phone. So everyone who can do, you can still taking pictures of almost 8 seconds, and that's it. You don't need any more. So thank you for inviting me.
Thank you.
And well, I think I'm going to sleep.
Yeah, get some rest. Get some rest. Have some coffee ready for when you first wake up. And
it's a nap only.
Yeah. Yes, my fiance is coming home maybe 5 o'clock. Maybe 6. He's a nurse. Yeah. He's working right now. So I'm talking right here now, because if she's here, maybe not. But she told me that maybe I can fall out from the rooftop, and she wouldn't help me if I fall out.
Nice.
she will be sleeping, but okay. So I will leave you with Adrian. I try to be in the now start party, but my eyes are closing right now.
Okay.
So thank you, everyone.
Thank you, Maxi.
Thank you, Maxi.
Yeah.
Okay.
Okay. Nos vemos después. See you later.
All right.
Yep.
Nos vemos después.
Well, I'll be even quicker than that, because I've only got 4 slides. But
okay.
Yeah, we're gonna rifle through it right now. I'll share my screen. So those that are still hanging on, you're seeing a couple pictures I took January 2019. Unlike this lunar eclipse, it was cold. It was out there. I didn't have to cool my camera because it was 0 degrees Fahrenheit when we took these photos. So I'll move this over here and I will play the slideshow. So this is with an old 30D. I took this photo as the moon was being bitten in half. The shadow crept up. This photo, you have the beehive cluster over here. It wasn't, of course, the best of photos, but my thing was you can see stars during the total eclipse or during the total lunar eclipse. Here's an image. You've got some starlight. Are they the best images? No, but they give you an idea of what you see when totality happens at night. This image I like a lot just because I was able to image that many stars. There's the moon during totality. You don't often think about when you see images of the moon. We may not think about the fact that there's all these other stars. Now, when it happened in 2019, what was it? 2017, I think, or I forget, but it was it was directly overhead, and this is just about south right here, and you were able to see all of the stars and image all of the stars as if you were shooting a moonless night scene. You just had this darkened moon, which I actually brought up the exposure a little bit.
Oh, that's cool.
And that's the moon, and these are all the stars. Not shot with the equipment that I have today. If the opportunity came back, I would of course try and shoot this, with the equipment that I have now and get more Milky Way here if it were, during the winter. But that's the, with lunar totality, you have the sky back. And then as it goes away, the moonlight brightens back up and, your sky gets washed out again with the moon.
Adrian,
so,
that was a stacked picture.
This was not a stacked picture. This was a 10-second exposure with a kit lens, at f3.5, ISO 1600 on an old 30D APS-C camera.
You diaphragm the picture, the lens. No.
Yeah, the lens was a kit lens. It is like a lens that comes with the camera when you buy it stock. And this was one of those where I didn't even use a tracker on it. I didn't have the tracker at the time. I went with, a 10-second exposure, and then, I didn't get as much detail in the stars here. But my whole point of this shot was stars, and just seeing, the moon's in the sky, but yet you can get all of these stars. And this was in the backyard of a house of a person. Sadly, is no longer with us, but his skies were maybe Bortle 4 to Bortle 5. It was pretty decent. We would go there and visually observe in the back of his house. And on this night, it was near midnight when lunar totality occurred, and we took a few pictures. We went in every few minutes because it was cold. I mean, the Fahrenheit scale hit 0, so it was definitely cold. So, that's my lunar eclipse, my best lunar eclipse story. I've seen the solar eclipse.
One.
Yeah, I'm hoping to get some. I'm hoping to get some better images, as time goes. And I'm actually debating whether I'm going to get up if our cloud cover. I will briefly share one more time, and then Christopher, go, because I'm going to be in. You all can enjoy. This site is showing that right around the time this whole thing starts, at my house, I've got mid-level clouds and low-level clouds. I don't know, there aren't many high-level clouds, but it's like this is, go time is right here, and then you've got sunrise. It goes below the horizon. When it gets into here, the moon's gone. So it's not looking good, which just simply might mean I may be sleeping through it. If there's a break in the clouds at all,
watch it live online.
Watch it live online. Yeah,
Yeah.
That's what I'll end up doing. I'll get up and just watch it live
Yeah,
with everyone else.
That's right.
Or I'll see how I feel.
Peek out the window, see if it's clear, but other than that.
I try to zoom it if I can with my cell phone in the app. So
okay.
Yep. Yeah, I'll watch along. So yeah, that's it's gonna be fun. It's a sun rising lunar eclipse, and I did see one of those before. We saw one. We had somebody, Brian Autumn, who I'm trying to get you in touch with, Scott, that also does remote astrophotography. So his rig was in Mexico at the time of a total lunar eclipse. It was just like this one. It would only show up in the western part of the globe. We were able to watch it in the morning at his house as he remotely projected it. So it was cool to see. So
that is cool.
Yeah. So it's basically similar to what's going to happen in another 4 or 5 hours.
Yeah.
Right here. So
that's awesome.
Yeah. So
awesome.
That's my presentation, and I'm sticking with it.
Thanks, Adrian. Thanks for coming on again. And we look forward to seeing you on the next Global Star Party as well.
Looking forward to it.
So all the way from the Philippines, we have Christopher Go on with us. And I trust you had a good lunch. And what do you got in the scope, Chris?
No, I'm right now in my office, so I'm happy right now because it's daytime here. It's about 12 noon,
that's
so
okay.
That's why I just had my lunch, and unlike you guys, I don't have to wake up early. Totality is around 7 p.m. here, so unfortunately, we won't be able to see the whole partial phase because the moon will be rising partially eclipsed. Usually, I would image the eclipse using a DSLR and my Celestron C8 with a reducer, but for the past few days, I've been trying to test a new camera that I got from QHY. It's a colored cam. It uses an IMX 485 chip, and let me share my screen. Okay. Okay. So here's an image of the moon that I took using a 70mm refractor. This one.
Wow.
Yeah.
Nice.
So now if you want to say wow, this is what I mean by wow.
No way.
70mm.
Yeah. This is incredible. A 70mm refractor, and this is an 8-megapixel camera, and I might be using this camera for the eclipse. It's a BSI back illuminated chip. So the problem with the DSLRs or the DSLR that I have is that it still has that IR or that H alpha blocking filter, and because when you have an eclipse, the moon is red, so this camera will be far more sensitive. And if you can look at the resolution of this camera, I can get probably a higher resolution than just using a DSLR. So I'm excited with this. This is an example of an image of the eclipse using my C8.
Yeah.
So
a beautiful copper color. It's really pretty.
It's blurry.
It's blurry.
No, you can see some details, but not as sharp as the. So I'm excited with what I can get with the new camera. And the reason why I also wanted to use this camera is because if I use a DSLR, we're not going to get any live view. And I was just thinking of you, Scott. So, with this camera, not only will I get a higher resolution, but also a live view. Everybody can see what I'm capturing. Remember when we were having the conjunction?
Yes.
Where you had a live view? We're going to do the same.
that's great.
Tonight. So
okay.
While I'm imaging, I'll be capturing in between. So this is going to be a short totality. I mean, this is the shortest I think I've ever, as far as I can remember, this is the shortest totality I've ever experienced. Here it'll be around 18 minutes, more or less.
Mm-hmm.
Yeah, so it's a fairly short. So I plan to take an image every minute. So one thing you'll notice, tonight the moon will not be completely red. So the I think one of the edges, I think the northern edge, is gonna be bright even during totality.
Right.
So it's gonna be like this one. This image here, you can see the bright, part of the moon is bright. In fact, it'll be brighter than this one because this was a fairly deep eclipse. So we'll see tonight. I was so depressed the last couple of days because we have a huge cloud cover in our area. There was this is supposed to be dry season, but we had a tropical depression a few days ago, and would you believe we're actually at the tail end of the cloud, and right now it's sunny now, so it cleared around 10 a.m. this morning, and the wind from the northeast, everything east of us is clear. So I'm confident. That's why you know how depressed I was when I kept messaging you, Scott.
Right. It's like bah humbug. Well,
but I think we're gonna have something tonight. So
that's great. That's great. Well, I'm glad.
Crossing our fingers, and we're gonna have a very nice live view, very high resolution, even with a 70-millimeter refractor. So,
that'll be great. Okay. Well, that's wonderful. Okay. Well, that's great. For those of you who don't know Christopher Go, he's world renowned for his planetary images. He lives in the Philippines, but he's traveled around the world to be at astronomical conferences, to give talks and lectures, and to show his work and to share his ideas. And we've all been inspired by him. Christopher also put on during that great conjunction, just an amazing, panel of people that, that showed the. Was it that time, Chris, when you hosted the Global Star Party?
No, it was different. We had an Asian version of the Global.
That's right. Oh, that's right. We had an Asian version, and he had he had amazing people on. He had a guy on that had his mount mounted in his bedroom. Okay, in Singapore. And it's just aiming through a little window. Okay, and it's just like let's just move the telescope back and forth to get these amazing shots from Singapore.
Incredible images.
Incredible images. Yeah.
from the bedroom.
Now there's no excuse anymore. I don't want to hear it. Okay. If this guy can do that, I don't know how he polar aligned in this room, and the telescope is almost up against the wall. Okay. Of his bedroom. Amazing. So just undaunted amateur astronomers, never tell an amateur astronomer he can't do something because they'll figure it out, So it was amazing. Anyhow, I look forward to doing that again. That was just such a fun time.
Anyway, I can give some tips for those who plan to image this one. Especially for the first timers. Be mindful of the focus. Try to focus before totality. And for those of you using the DSLRs, what you should do is, there's a live view on, not just DSLRs. Right now, I'm sorry, we are using mirrorless right now.
Right.
But for those of you who are using cameras, try to get into live view. And what you do is there's a zoom feature. Just zoom to the deepest zoom and focus from there. And once you get the focus, lock it. If you plan to image, you need at least 400 millimeter and above to get a decent image of the moon. But focus is very important. during partial phase, after you focus, you can leave it for totality. When you do totality, as I think some of you may have said, it's gonna be like a little deep sky imaging because the moon's gonna dim up. It's not gonna be totally like moonless, but it's still gonna be pretty dim. You'll probably go to exposure times of about 1 to 2 seconds, and in most cases you'll be able to see stars. So just be patient, and also don't forget, for those of you using cameras, capture in RAW mode. You get better image quality that way. Hi, Simon. Hi, buddy. Nice to see you again.
Sorry, I'm muted right this second because I actually have a gap in the clouds, but for all I know, this could last long enough until whatever o'clock. I'll be back.
You'll be back. Okay.
Scott, if you let me, I want to thank you, Christopher Gove, because when I started to do planetary pictures, I saw all the YouTube tutorials, and that's helped me a lot to practice with wavelengths and registags and everything. And welcome. Also with Chupos. So it's a pleasure to be here with you and talking to you right now.
Yeah, it's my pleasure also to be here. It's great to see you guys.
Yep. By the way, Chris, you have some questions. One of them is from Harold Locke. He was looking at that image of the black and white image that you had of the moon there, and he wanted to know, is that QHY image stacked or a single shot?
It is stacked. It's a 30-second capture.
Yep. Okay.
So it's about probably 1,000 images.
Mm-hmm. Oh, wow. Okay. All right. And then we have Beatrice Hines out of Belgium, and she's asking, how do you like the Nick collection for editing? Is it worth the buy?
Actually, here's a secret. There's actually a free version. Just Google Nick. There's a free version for that. I actually use Nick for sharpening. In fact, Nick was used to pre-sharpen this image of the moon. So wow. I do use Nick. I do use Nick. It's a good software. There is a free version. Just Google it. But the problem is it's not going to work with the latest version of Photoshop. Probably the older version. But I would say it's a good software for sharpening.
This is I see something that says download the latest version of Nick collection by DxO. Is that it?
DxO, there's an older version, because what happened was that Nick used to be Nick, then Google bought it, then Google gave it away for free for some time, and for those of you who can download the free version, it was about a year. Then what happened was that Google sold it to DxO. Just Google Nick collection free. I think there is still
there's something called lenscraft.co.uk. It says how to download the Nick collection for free.
Free, yeah. Okay, yeah. There's some. Okay, there's actually download. Is it possible to get free download? Yeah, you just go through those links, and there is a free version. But as I said, it's not going to work with the latest version of Photoshop, and you need Photoshop to run Nick. So, but if you have the latest version, I would say go ahead and buy it.
Yeah, $150.
Yeah,
less than the cost of an eyepiece.
Just wait for July 4. They normally have a big sale.
There you go. There you go. Awesome. Okay. Well, that's wonderful, Chris. Does anybody else have anything to add before we take a few-minute break here, and then we'll come back with the after party and finish up with any other comments before we try to get a little shut-eye before eclipse time.
What? I'm just getting started.
I've got a live view of the moon, so...
Oh, wow, nice.
Not that much special, unfortunately. Although this is actually, if you're wondering why is it so small, I'm actually using my GFX camera. As soon as Chris stops his screen share.
Wait a sec. Let me stop this. Okay.
There we go. So yeah, you can see the moon right there.
Indeed.
Yeah.
Hey, I see some chromatic aberration. Is that or?
That red is telling me that my image is in focus because I'm actually connected directly to my GFX camera, so you can see me doing everything. So if I do a playback, it shouldn't.
Comes back twice as strong.
Oh well, it just doesn't work at all. One of the two, and does that. So you can see. I haven't actually tried this before doing it with this particular setup, so it's still relatively new in that fashion. But I will get a regular astronomy camera back on there. I just thought I'd take a couple of shots with my GFX camera because I quickly ran outside because I noticed there's a great big band of cloud wafting up over there. You can't see it, but the moon is low enough down this side for me to get it. When it gets all the way to the other side, you'd actually see it theoretically in the background over there, but my house is in the way. There is a tree in a mountain, and I know this area so well that tree sits, the top of the tree sits at exactly 25 degrees.
Go and cut it.
It's going to screw me no matter what.
Go and cut it. You have time.
This tree is huge. This damn tree is like 78 feet tall. It's like, who put that there?
That would not be good. Yeah.
Hey, I have a nice view to show you guys.
Wow.
So this is with I think an astrophysics 5-inch shear factor. The
Beautiful.
moon, and you can see with background stars. So,
Love it.
Where's the moon tonight located?
In Scorpio.
Oh, this is gonna be nice. So we can see the galaxy.
Actually, I know somebody who's going to be doing a somewhat long exposure, so it'll show up right next to Rho Ophiuchus because I believe Antares is right next to it. And
it's almost close. I think. Well, here is the left of the arm of Scorpio. No, the right. The right. Sorry.
Hold on a second. I've got to fix what this weird problem is.
Okay. How do I
guys.
stop sharing?
I have to go to bed.
Yes, that's right.
It's almost.
Maxie, thank you. You have you stayed the course. That's wonderful. But get some rest, and then we'll all try to come back.
Okay. I will try to be online in Zoom. So maybe I can do because I will with my cell phone. I have the two cameras. Maybe I can change the camera so you can see in live view the moon.
Okay. Yeah,
let's see
that's
what
great.
happens.
I will start. I'll start the broadcasts or the Zoom login early at about what did I say? 3 o'clock my time or something like that. So
what time is it right now where you are?
It's 11:47 right now.
Yeah. Okay.
And let's see.
So we have 2 hours from difference.
Yes.
Yeah, it's 0547 UTC.
So the early log on will be 4 a.m. my time.
Okay, so 6 a.m. Okay.
Make sure you wake up, Scott.
I don't think I'm going to go to sleep.
Really?
If I go to sleep, it's dangerous because then I won't wake up. So,
I remember when we had that one.
Eat a sandwich, take a shower, and then I'll be back. So,
okay, guys. See you later. So,
all right.
Buenas noches.
Buenas noches.
Nos
Thank
vemos.
you so much. Nos vemos, Christopher. Un abrazo.
Hasta luego.
Well, great. So, do you guys want to take a little break, or do you want to continue on?
Let's take a little break so I can get this guy up on there because, like I said, I was just
all
messing
right.
with my other camera.
Okay, bio break for me, but
yeah. All right, so here we go.
And then
Hey,
Simon,
what camera are you using? That's a huge one.
Wait, which one? This one or the one that I've got up there?
That one.
It's the 2600
Ooh,
MC.
Color. Wow,
yeah, this is a
that's
color.
huge.
Well, of course, it's the Eclipse. We want to see it in color. But yeah, I got to get this sucker on there first.
Yeah. My problem is that I don't have a big color cam. I only have a, yeah, I only have a monochrome.
Yeah, no, this camera is so overkill for this purpose. But you know, if it's worth overdoing, let's just do it anyway. All right, let's go for your bio breaks. I need to, you know, mess with stuff here.
Okay, bye.
Okay, guys, see you tonight. I'm leaving also, need to work.
Okay.
Okay, Scott, bye.
Well, hello, everybody. We are back in what we call the after party, and it looks like it's just Bob Denny, Simon Tang, and myself at this point. Christopher Go has left the room, and Adrian Bradley is off to sleep, and so it's up to us, guys.
Hey, Simon.
Yeah.
You know what, Scott? We need to let Scott go. The two of us can hook up later.
Let's see what Simon's got here. Let's see what he's got. We got a few minutes.
Okay, all right.
Hold on.
Sorry.
I got to reconnect the device because I don't know why it's desynced.
I'm sorry. I thought, Simon, though, whatever we want to talk about, we can do it later.
Yeah, we could always do another session.
Yeah.
I don't know why it's doing
What's
this.
going on
whatever
with
you're
your,
doing, that's cool.
Well, there's always one way to skin a cat, as they say. So if I do it this way, screen share. Where's desktop gone? Oh, screen, here it is. Share.
There you go.
Yes, we have a moon right now. This is with
Right.
the 2X Barlow and the 2600. Yes, it's a little overexposed right this minute. And
That looks great.
in color, believe it or not.
Oh, yeah.
But yeah, I completely forgot that this camera with a 2X Barlow, runaway deck, with a 2X Barlow, the extension tubes that you need is quite severe.
Right.
So yeah, we have a moon. Like I said, there are clouds. It's kind of hard for you to see.
Is that what's going on right now? We see it kind of dimming down a bit.
Yeah, it'll kind of blink. You'll see it dim down, and at some point, well, right now there's no big clouds patching in the way, but I'm looking over the far horizon, and I do see stuff happening over towards Los Angeles National Forest and the actual Angeles Crest Mountains, but they're far enough away. So I'm hoping that this is going to go on.
I think it will
stay like this for the next
I think it will.
5 hours.
It's going to clear up for you, I think. So
bright. Yeah, I think you had it brighter before, and if you brighten it up a little bit from at least our perspective, it would look there. That's good. That looks good. Yeah. Now we're getting there.
And something's flying in the front of the camera. Don't know what that was. No, it's not aliens.
Are you sure? Can you prove they're not aliens? That's what I want to know.
Yeah,
I can prove that it was not a UFO. Put it that way.
UFOs. Jeez. I'm so sick of hearing about those.
No, they're not UFOs anymore, Bob. They're UAPs. You know.
Do you believe in UFOs?
I believe in them.
God.
I don't know. There are people who, you know, it's okay to believe in whatever you want to believe, but is it science? You know? No, not yet.
Data versus interpretation, there.
Right.
But just so you know, Scott, the chances are I will probably get the penumbra, but I will not get the umbra.
Well, penumbra is good enough for me.
Cool.
Yeah, it's good enough for me. We'll be streaming early enough to cover parts of that as well. You know, it's part of the eclipse. And so, and you got a live view right now. So, you know, we're good. We're good. Yeah. It's all the astronomy experience, especially for an eclipse like this. And it's the only one this year. So,
right.
We got to get it. And it's a supermoon, right?
Well, yeah, that's probably why it's so damn big. It usually doesn't fill the frame like this. No, I'm kidding.
It's much closer, right?
It is much closer.
Well,
much closer and full moon.
I was going to say, what's the percentage of this moon? It's like 12% larger than usual. It's not a 14%. I know that.
Mm-hmm.
I've got to look that one up. But as you can see, this is not actually a completely full moon, because if you look at the top edges, especially up here, they are still in shadow because of the way the craters look there. So this is not a true
I can
full
see
moon.
that. Yeah, that's interesting.
Yeah.
Bet you guys didn't notice that.
Pretty cool.
Bob did. Bob caught it. I didn't. You know, I thought it was just full. You know, so
yeah, it's not a true full moon. It's like 99.8%. I think by the time we get to the eclipse, it'll be a true full moon. It'll be 100%.
It has to be, right?
Yeah. Well, yeah, you're right.
That's right. Otherwise, no eclipse. Sorry. Yeah.
Well, we're getting there. We're getting there. This is the beginning of the eclipse. You know, it's the important
really
part.
Cool that you can see that.
Mm-hmm.
I don't know if people at home can see all of it, but guess what we can also do?
Yeah, there you go.
Zoom in.
Just zoom in.
Oh, yeah.
The edge.
Check it out.
Oh, look at that.
Oh, there it is.
I love it.
There's some shadow.
Yep. You can see the mountains.
Oh, look at that crater right there. You know,
I love that.
On the very, very edge.
Yeah, the seeing is a little bit questionable for obvious reasons. That's why I have clouds, but you can make it out. And yes, Chris, if Christopher Go was still here, he'll mention that I've got chromatic aberration. Yeah, you're right, I do.
And he would show you something as a result of 1,000 frames.
Oh, yeah. I mean, I'm going to do a stack at some point. So, you know, I might just go ahead and do this. But I don't know how long Scott's going to stay up. I know, Bob, you're going to probably scoot off. But I'm going to be like Scott. If I go to sleep, I will not wake up.
Right.
I have an early trip to leave on tomorrow. So I'm going to probably beg off.
You better get some rest, Bob.
Simon, the stuff that we were going to talk about in the after party, I want to talk about, but probably better to do that not tomorrow because I'll be gone, but Friday maybe.
Yeah, I think, you know what, maybe we should get together, Scott, one day and as a star party,
sure,
a little something that's probably more about the tech side of things, and because I know you do your other live streams that are probably more suited for something like this, but I think having a discussion and a debate, because
it can be global star party. We can have just a separate session where it's a technical session. I mean, it can be a one-off. I mean, if you guys want to do a series, I can do a series. It's all I'm all good for it. So, you know,
well, that would be terrific.
We've got, for instance, we've got Caitlin Ahrens. She's doing a 7-part series once a month, and it's called 7 Months of Science. You know, so could be 10 months of technology. So, you know,
Ugh, that sounds ghastly.
I'm not sure
people will be like, "Oh yeah, right."
10,000 days of technology.
With your host,
10,000 hours. If I can keep broadcasting, I'll just keep going. Okay, so yeah,
24 hours of arguing about technology and why it doesn't work.
Right. Why your USB hub died. That's a big one.
That'll be at 10,000 hours of USB hub death. Yeah.
Okay. All right. Enough of that.
Why are we still using
Oh
cereal
God,
forks?
I must be punch drunk right now. So
me too.
All right, I'm going to get some frames in and just keep, and then put up a very, very, very big screen and to stop the clouds from rolling in. So
yeah,
that looks great.
It does.
You're ready.
Actually, we got. I could see like moonlight coming through the clouds here in Arkansas. It was so socked in earlier. Heavy rain, you know, during the day. So, anyways, I know the moon's out there somewhere. So, to all of you that were in the audience today, thank you so much. I can see Beatrice is still checking things out. Harold Locke is. Was with us. We had Mike Wiesner, Jeff Wise, a bunch of people here that were watching from around the world. It was really great. Had a very nice lineup of talks and you know, exciting astronomers to hang out with. If you could be at any star party and hang out with this group of people, you know, you would remember it for the rest of your life. You know, so. Hopefully, hopefully we've given you a taste of what that's like, and you know, and hopefully at one point we are all together in real life somewhere.
Yes.
But if I get that put together, Simon, you and I will have to team up and live broadcast it or something. So that'd be a lot of fun.
Yeah, definitely.
Yeah. Yep. And I do want to give a big shout out to you, Simon. I'm able to talk and close the show right now because of you. So thank you very much for helping me figure out what happened. What did happen is that I got a Skype call from Christopher Go, and Skype decided to take over my audio world, which I had very carefully balanced before the show. So, anyhow, I guess we will close for now. Bob, thank you so much.
You're most welcome.
You did not go on too long. You know, you were fabulous. You know, and
thank you for having me a lot. Thank you.
Anytime. You got a permanent VIP seat here. So, and for all of you in the audience that have not been on Global Star Party, definitely get in touch with us. We'd love to have you on, have you share your passion and your expertise or anything, your journey, even as a beginner. We'd love to have you on. So,
don't ever feel intimidated by us by any means. You know.
No. We were all beginners, you know, and I wish I could go back through the whole loop again. You know, it was fabulous, you know, and it still is. But I just wish I could go back and re-experience being a beginner. You know,
your Saturn V thing opening. Other people said the same thing, but I've got to tell you, that was unbelievable.
Yeah. Well, thank you, NASA. You know, so.
Well, but you kind of put it together.
Yeah, I did. I sequenced it. That's true. That's
awesome.
True. I had to go out and find it. So, and it was fun. It's great that, you know, I do thank NASA. I'm a NASA Solar System Ambassador. They give us such great resources. I give the whole public great resources for that, but so does the European Space Agency, ESA. I mean, they pump out the videos too, and they make those available for all of us that like to do educational outreach, or, you know, if you're a teacher or whatever, if you're listening and you want to know how to get to those videos or whatever, get with me. I scour the web almost every day for videos like that. So, and it was fun. So we'll see you guys again. The time that we will be, yeah, that's right. In 4 hours, we're going to be back on with the early log on at 4:30 a.m. Central. 5:30 Eastern, 2:30 a.m. Pacific. We will start the live stream again. And anyone that's got partial views of the eclipse, we'll stream them going all the way up to the crescendo of totality. And we had several people say that they would try to attempt, and Simon's one of these guys for sure. But we've got Molly who's going to be waking up. Christopher Go is going to be there. Caesar and Maxie, they both might do it. Jack Newton, there's an outside chance that Jack might do it as well. He runs an astronomy bed and breakfast in Osoyoos, Canada, up there, and just above Washington State. And so if he can get some clear skies and a little bit of time away from his audience that he's taking care of, he'll try to live stream as well. So we'll see what happens. Anyways, thanks everyone for watching so far. I hope you liked it. And Beatrice, you're the last one commenting here, so thank you very much. It's great to have you on, and we'll see you. Okay, that's it. Good night, everybody.
Good night.
All right. I'm going to blow out of AirScope, so I will see you in about 4 hours.
All right, Simon. Take care.
Okay, Scott. Good night. I'm out of here. I've got to get up early in the morning and bug out. So.
All right. Take care. Be careful, man. Bye-bye.
Thank you. Bye.
Yep. Bye.